In this video, I'm going to go through everything you need to know for GCSE for the topic of functions. So first off, we need to start with establishing what a function actually is. So we've got a definition here. It says a function is a relation between two sets of values, and it's a type of mapping. Okay, so let's just explore this a bit more. So I've got a function machine, okay, and I'm going to call this machine f. Okay, and at the top, I'm going to put some input into my function machine. So in here are going to be my inputs. And then that's going to be one of my two sets of values, which this function relates. And then out the bottom will come my outputs. And this is the other set of values mentioned here. So the mapping is the function, okay? And the function is going to map my inputs to my outputs. So let's start inputting some numbers. So I'm going to create a table, okay? And we're going to call this the inputs. And then the bottom part can be my outputs. So let's say into my function machine, I was to input a 2. And let's say the output was a 4. Like that. Okay, so our function f has mapped the number 2 to the number 4. And I want you to start thinking, what might the function actually be doing to the 2 in terms of a mathematical rule? But I'm going to give you another pair of inputs and outputs. So let's say I was to input 5, and then the output was 25. And then let's say I was to input -3, well then the output would be 9, like that. Now once again, I want you to think, what's the mathematical rule going to be? And hopefully you've established that it's going to be squaring. Okay, if you square 2, you do get 4. If you square 5, you get 25. And if you square -3, well, -3 times -3 would give +9. So my function f is squaring. Now what we need to think about next is how can we write this function out using some new notation. Okay, so first off, let's just label what we're going to call our inputs. Our inputs are going to be our x values. Okay, so we're going to call our inputs x, and we're squaring. So essentially we're taking x and we are squaring it. So I would write x squared on my page. Now some new notation that you need to be familiar with for functions is that we would write, if our function is f, I would write f of x like this is equal to x squared. So what's written here, I would read this out loud as f of x like that. Or what you could say alternatively is that f is a function of x, because x is what we are substituting into my function. Now just to be clear, this f here is not multiplying the brackets, okay? You can't divide by f. This is just special notation that we use to represent a function. Now you don't have to use the letter f, you could use a different letter, and you don't have to say that x is necessarily your input, but we're eventually going to relate this to coordinates. So of course we have x coordinates, hence why I picked x. But if you wanted to, you could put a t there and then a t here like that. And then we say f is a function of t or f of t. But I'm going to put it back to x like this. Now what I'm going to do next is write out some of our inputs and outputs using the new notation that we've just talked about. So let's focus on this pair of inputs and outputs. Okay, so the input was 2, so 2 is your x. So what I can say is that f, and then in brackets, I'm going to put the 2, which is the x value. So I'm going to replace this x with the 2 up here. And that would be equal to my output, which is 4. So I would say that f of 2 is equal to 4. Now let's think about another statement we could write using the pair of values on the end here. Okay, so it'd be f again because that's my function. And this time my input, my x, is -3. So I can say f of -3 is equal to my output, which is 9, like that. Now let's have a look at a different function machine, which is going to have a different rule. Okay, so here I have another machine, and this time I'm going to call my function machine g, because f is a different function machine which we've already encountered. So once again, we're going to have our inputs going into here, and then we're going to get some outputs from here. Okay, so the idea is the g, the function, is mapping our inputs to our outputs. So let's draw my table for my inputs. And then at the bottom, I'm going to put my outputs. And we're going to call our inputs our x values. Okay, so let's say I was to input the number 3 into my function. And let's say the output came out as 7. And let's say I then inputted 10 into my function. And then the output I got out was 21. And then let's say the input was 17. And then the output came out as 35. Now, once again, I want you to think, what is the mathematical rule that is linking our inputs to our outputs? So then we can write out our function g. Well, if we compare these pairs of values, okay, if you double 3, you get 6. If you double 10, you get 20. If you double 17, you get 34. So in every single case, once you've doubled your inputs, we are 1 less than our outputs. So we then need to add on 1 in order to get to our outputs. So what we're doing is we're taking our inputs x, we're multiplying them by 2 because that's what doubling is, and then we add 1. So this would be my function. Because it's called g this time, I would write g of x is equal to 2x plus 1. Now let's try and write some statements out using the pairs of values in my table. So let's say the 3 and 7. Okay, the input x is 3, so I would write g of 3 is equal to my output, which is 7, like that. Now let's use the 10 and the 21. Well, my input x this time is 10, so I would write g of 10, and then my output is 21. Okay, so I write equals to 21. When it comes to my notation, the last thing I want to consider is what is the g of x essentially taking the place of that you're used to? And the same for the f of x back in this statement here. If we look at this one, what is the f of x essentially taking the place of that we're used to encountering? Well, if you think about coordinates, x is sort of your input, and then your output is your y coordinate. So f of x is essentially taking the place of y. So the question you might then be asking is, why not just write y? Why introduce this new notation? Well, as this video progresses, we're going to learn to do lots of things with this notation, okay, that we wouldn't be able to write out if we just had y written there. However, the other thing is, you can't take any equation with y in it and necessarily claim it's a function. So what we just have to consider is one other feature of functions, and that is each input must only have one output. So let's say I have my table of inputs and outputs. And let's say into my function, I was to put 2 into my function and out came 7. This time, don't worry about a specific mathematical rule. Okay. Now let's say I was to input 3 and then 9 came out. And let's say I was to input 4 and then 13 came out. Okay. This so far could definitely be a function. Okay, because each input is only having one output. Okay, and let's say I was to input 12 and then 13 came out again. That's fine because each of the inputs 4 and 12 only have one output, 13. Okay, they can have the same output, that's okay. However, what can't happen in a function is, let's say I was to input 12 into my function again, and let's say now the output came out as 23. This cannot happen in a function. You cannot get 2 different outputs for the same input. Okay, the idea is if we input 12, we should get the same value every single time if it's a function. So this value here should be coming out as 13 if this is going to be a function. So thinking about the graphs that you've learnt so far in maths, which graph for one input might have multiple outputs? Well, one graph you could consider is the graph of a circle. So I draw a circle here, and let's say we were to pick one input, so an x value, and let's say that input was this value here, so we'll call this x1. Well, let's consider the outputs I get for this input. Well, if I go up to my curve like this, I hit the curve there, so I could then go across, and that is one output there, which you might call y1. Now I am just going to extend my axis a little bit. So we got y here. Now let's say we then went back to our x coordinate and kept going upwards. So we could go up like this. And we're going to get another output if we go across. which is y2. So for this single value of x, we've managed to obtain two y values on my graph, so a circle cannot be a function. Now let's consider a graph that could be a function. So let's draw a linear graph, as that should be a graph that you are familiar with, like this. Okay, and let's mark on my x-axis, and we're going to pick an input. Okay, so we're going to call it x1. Now, if I was to go up to my curve like this, I would hit the curve there, and if I was to go across, I would get an output. However, that is the only output I could have. If I went sort of down or up further, I'm not going to hit my curve again. Therefore, y1 is my only possible output, so this can be a function. Now, in the case of a function and drawing a function, we wouldn't label this axis y, because we said that what takes the place of y is our function notation, so I would write f of x like that. Now let's practice using some functions that are given to us. So let's have a look at our question here. So we're given three functions. We've got f of x, then we got g of x, and then we got h of x. So in any given question, you need to decide which one is the one that you've got to use. So let's look at part A. It says calculate f of 2. Okay, so f is the only function present here, so therefore I need to make use of f of x is equal to 3x subtract 5 like this. And I'm being asked to calculate f of 2. So I'm going to write f of 2 here. And the idea is this x here has been replaced with a 2. Therefore, I need to go to the right-hand side here and replace all of the x's with a 2. So what I'm going to do is put brackets around any x like this, and then I'm going to replace what's in the brackets with a 2. So I'm going to write 3, open bracket, and then a 2, and then subtract 5. So the only thing is changing is that x inside the bracket. Let's then calculate this. 3 times 2 is 6. Subtract 5 would give me 1. Therefore, f of 2 is equal to 1. That's my final answer to A. Now let's have a look at B. So it says calculate h of negative 4. So this time h is my function, so I need to make use of this function here. It would be incorrect to use g or f. So I'm going to write h of x is equal to 2x squared, take 3x plus 7. And then directly below the h of x, I'm going to write h of negative 4, which is what I'm trying to calculate. And once again, I'm just going to go to my initial function, and I'm going to put brackets around all of the x's. Because if I want to calculate h of negative 4, then what has happened here is the x has been replaced with a negative 4. So I need to go to my right-hand side and replace all of those x's with negative 4s. So I'm going to write out the exact same statement, but in place of the x in the bracket, I'm going to write a negative 4. So I have 2, open bracket, negative 4 squared. Then subtract 3, open bracket, negative 4, close bracket. And then we got the plus 7 on the end. Like that. Then we need to calculate this. So you could put this into the calculator if it was a calculator exam, but let's do it non-calculator. Well, if we square negative 4 times negative 4 is positive 16. Okay, which I'm then going to multiply by 2 to get 32. And then we've got negative 3 times negative 4. So that's going to give me positive 12. And then we got positive 7 here. And then if we add those up, I get a total of 44 plus 7, which is going to be 51, which is my final answer to part B. Now let's have a look at part C, which is a little bit different. So in part C, it says solve, so a different keyword here, and it says f of x is equal to 6. The most common mistake on this type of question is to substitute 6 into this expression here, into f of x. This is wrong. That would be correct if the question was calculate f of 6, which is not what the question is. The question is asking us to solve f of x is equal to 6. So this is asking what value of x would make my function equal to 6. So if you look at f of x up here, what you could start doing is guessing values of x you could put here, which is then going to give us 6 out of this calculation. However, this is inefficient. What we want to do is form an equation. We want this expression, 3x subtract 5, to be equal to 6. So I'm going to write that equation out on my page. I would write 3x subtract 5 is equal to 6. and then I have an equation I can solve by rearranging. We would add 5 to both sides, so I'd get 3x is equal to 11, and then we'd divide by 3 on both sides, so x would be equal to 11 over 3 like that. And that is a much faster method than guessing, because you're never going to realistically guess 11 over 3. Let's now have a look at part D. So part D is once again solving. So we're not going to do any substitution. Okay, we need to solve f of x is equal to g of x. So this is essentially asking what value of x would make the functions f and g equal to each other. So I need to make use of f of x, which is the 3x subtract 5, and the g of x, which is the 1 subtract 2x. And I want to know which value of x would make them equal to each other. So I need to equate those two circled expressions. I need to write 3x subtract 5 is equal to 1 subtract 2x like that. Okay, and now I have an equation that I can solve. So I'm going to start by getting all my x to one side. So I'm going to add 2x to both sides. So I would get 5x subtract 5 is equal to 1. Now we got all our x to one side. We're going to add 5 to both sides. So we get 5x is equal to 6. And then we're going to divide by 5. So x is going to come out as 6 over 5. So what we've found here is the solution to part D. And essentially what this means is if I substituted this value into both f of x and g of x, I would get the exact same output. However, we don't need to know that output. All I wanted to know was that x value I found there. Now let's have a look at a more challenging question. So this is a separate question. We have f of x is equal to 5x plus a. That's our function this time. Now we're given that f of 3 is equal to negative 2, and we need to somehow find the value a in my function f. Now this bit of information is what's going to help us find the value of a, because this is telling us if I substitute the 3 in for x, my output of my function should be the negative 2. So what we're going to do is form an equation using this bit of information. I am going to substitute the 3 into the 5x plus a, and then I'm going to set it equal to the negative 2. Okay, so I put brackets around my x, and now I'm going to substitute my x value of 3 in. So I would have 5 multiplied by 3 in the brackets plus a, and that's going to be equal to the output here, which is negative 2. And now I have myself an equation which I can solve to find a. So if we simplify, we got 15 plus a is equal to negative 2, and then subtract the 15, so we get a is equal to negative 17. And that would be my solution. So that's quite a handy thing to do if you're given a statement like this one here, okay, to substitute the information into the function and equate it. Now let's look at a harder version of this question. So now we've got g of x is equal to 3ax take 2b. So we now have two unknowns, a and b. And we are given a bit of information saying g of negative 1 is equal to 7. Therefore, if I substitute negative 1 in for x in my function, my output is going to be 7. Then we've got another statement which is saying that g of 3 is equal to negative 5. Okay, so that's saying if I substitute 3 into my function, g, the output is going to be negative 5. And we need to find a and b. So what I'm going to do is form an equation based off both of those circled bits of information. So let's start with the one on the left. I'm going to substitute negative 1 in for x. So if I put brackets around my x, I would have 3a multiplied brackets by negative 1. And then we've got the subtract 2b. And this should be equal to 7. Now let's just simplify this. So negative 1 times 3a would be negative 3a. And then we got negative 2b is equal to 7. So I have an equation linking a and b. However, because there's two unknowns in there, I'm going to need another equation linking a and b to help me find a and b. So let's use my second bit of information over here. So I'm going to substitute 3 into my function. So I would have 3a. And then in brackets, in place of the x, I'm going to put the 3. And then it's going to be subtract the 2b from the function. And then it's going to be equal to my output, which is negative 5. Now, once again, let's simplify. If we have 3a times 3, well, that's 9a. And then we got subtract 2b. And that is equal to negative 5. So now I've got a second equation linking a and b together. Now what I'm going to do is just write this second equation over here beneath the other one. So I'm going to say 9a subtract 2b is equal to -5. So we have a pair of simultaneous equations that I need to solve. Now if we look at the b's, we've got -2b and -2b here. So we shouldn't have to multiply the equations by anything. We are now in position to either add or subtract. Now if they're both negative, we are going to want to subtract my equations like this. So we'd have -3a subtract 9a, so that's going to become -12a. And then we would have -2b subtract -2b. Well, that's going to become add 2b, so we're going to get 0b. That is why I decided to subtract. And then finally, on the right-hand side of my equation, we've got the 7, and we're going to subtract the -5, so therefore we're going to have to add 5, so that is going to give me +12. So we end up with -12a is equal to 12. So we now have a equation in one unknown which we can solve. We can divide by -12. So we would get a is equal to 12 divided by -12, which is -1. So I've got my value of a. I now need to substitute it into one of my simultaneous equations in order to find b. So I'm just going to sub it into this one over here because I've got it written out on the side. So in place of the a, which I'm just going to put brackets around, I'm going to write 9, and then in brackets -1, which is my value of a, subtract 2b equals -5. But let's simplify it. So we'd get 9 times -1 is -9, subtract 2b is equal to -5. So there's only one unknown in the equation, so let's rearrange and solve. We got -9 here, so we're going to add 9, so -2b is equal to +4, and then we're going to divide by -2, so that's going to give me b is equal to 4 divided by -2, which is -2. So a is equal to -1 and b is equal to -2. Now let's have a look at substituting algebraic expressions into my functions. We're now going to look at substituting algebraic expressions into functions. Okay, so we've been given a function here called hx, and it's equal to this quadratic here. We're being asked to find h of 2x. So that's how I say it out loud, h of 2x. Now let's just remind ourselves of how we'd find h of a numerical value. So if we have h of 3, then what we would do is we would substitute the 3 here in place of x in function. So wherever there's an x on the right-hand side, you'd replace it with a 3. We're going to do the same for algebraic expressions, okay? The same process works, it just looks a little bit more complicated. So if I need to find h of 2x, what I'm going to do is go to my initial function h, and I'm going to put brackets around wherever there's an x. So we've got an x here, so I'm just going to put brackets just around the x, like this. And then we got x over here, so I'm going to put brackets around this x as well, just like this. And then what I'm going to do is replace all of the x's in the bracket with the 2x here, because the idea is the x up here has been replaced with a 2x, so I need to substitute 2x into my function. So what I'm now going to do is write this statement out, but in place of the brackets, I'm going to put a 2x in there. So we would get the 3 at the start, and an open bracket, and in my bracket I'm going to put 2x. So I'm going to write 2x, close my bracket, and then we've got the squared here like that. Then we've got the subtract 4, and then we've got open bracket again, and I'm going to put the 2x into that bracket, and then close my bracket, and then we've got the +5 like this. Okay, and that is my function h of 2x. Now I should go through and simplify my function. So let's start with our indices here. If you have 2x squared, that means 2x times 2x, which is 4x squared. So I would get 3 lots of 4x squared. And then it would be -4 times 2x. So that's going to give me -8x. And then we've got the +5 on the end. Then my final step is to do the 3 multiplied by the 4x squared. So that is going to give me 12x squared, subtract 8x plus 5. Which is my final answer. That is the function h of 2x. Let's move on to my next one. So my next one says h of x plus 1. So wherever there's an x in my initial function, I'm going to replace it with x plus 1. So inside my brackets here, I'm going to put an x plus 1. So we would have the 3 at the start, open brackets, and then in my brackets, I'm going to write the x plus 1. And remember, it's going to be to the power of 2 because we've got a power of 2 there. Then next we've got our negative 4. And then open brackets. And then I'm going to put the x plus 1 into my bracket. And then we got the plus 5 at the end. So that would be my function h of x plus 1. Now, once again, we should probably simplify. So to get that process started, I need to expand x plus 1 to the power of 2. Now, remember, x plus 1 to the power of 2 means x plus 1 times x plus 1. Because you are squaring what's in the brackets, you are multiplying it by itself. So let's do the expansion. So let's start with this x here. We're going to multiply by x to get x squared. And then we're going to use that x to multiply by 1. So we get plus 1x. And then let's move on to the next term in my first bracket. So then we got 1 times x, which is 1x. And then finally, we have the 1 in the first bracket times the 1 in the second bracket, which gives me 1. Now, if I simplify that, I get x squared plus 2x plus 1. So what I now can do is substitute that into my expression for h of x plus 1. So I would get 3 lots of, and I'm going to replace the circled part with what I have found over here. So I'd be open bracket because it's multiple terms, and we've got x squared plus 2x plus 1, like that. Close bracket. And then we got the negative 4 multiplying this bracket here. So negative 4 times x is negative 4x. And then negative 4 times positive 1 is negative 4, like that. And then we've also got the plus 5 at the end. Don't forget about that. Now, we also have to expand this bracket here by multiplying by 3. So we get 3x squared plus 6x plus 3 when we multiply all 3 of those terms by 3. Then subtract 4x, subtract 4, plus 5. And then collecting like terms, we'd have 3x squared, and then we got the plus 6x and a negative 4x, so that's going to be plus 2x. And then we've got the positive 3, the negative 4, and the positive 5. Okay, so that's going to leave me with positive 4, like that. So that would be h of x plus 1. Now, we've got one final part for this question, so I'm just going to declutter what I've written up here. And for this one, we are being asked to find h of negative x. So wherever there's an x in my initial function, I'm going to replace it with a negative x. Inside my brackets here, we are going to put a negative x. So I would write 3, open brackets, negative x to the power of 2. Then we got the subtract 4, open bracket, negative x goes into the bracket, plus 5, like that. And then we just have to simplify. So if I have negative x times negative x, because that's what squaring means, you're going to get positive x squared. So we would end up with 3 times x squared. And then negative 4 times negative x, well, that's positive 4x. And then we got the positive 5, like that. Okay, and that will be my function for h of negative x. Now let's have a look at a question involving solving equations. Okay, so here's our question here. We've been given a function g of x, which is equal to x squared take 4x. And then we're being asked to solve this equation down here. Now, when we're being asked to solve this equation, we're being asked to find what x is. And essentially the value of x that is going to make g of x plus 4 equal to negative 3. So what we need to do in this type of question is we need to start by finding g of x plus 4. Because remember, the g is not multiplying the x plus 4. The idea is we need to substitute x plus 4 into g to find this function. And then we need to equate this function equal to negative 3 and try and solve for x. So I'm going to write out our steps here. So step 1 is going to be find g of x plus 4. Because I don't like the fact that there's function notation in this equation. I want to replace it with something. And then step 2, I'm going to equate my function g of x plus 4 equal to the right-hand side of the equation, which is negative 3. Like that. Okay, so let's start with step 1. So step 1 is find g of x plus 4. So I'm going to write g of x plus 4, and then I'm going to write equals to. And what I need to do is go to my initial function g of x, and wherever there's an x written, I'm going to replace it with x plus 4. So what I'm going to do to assist with this is on the right-hand side, wherever there's an x, I'm going to put brackets just around the x. So I'm going to put a bracket here and a bracket here, not around the power, just the x, and then a bracket here and a bracket here. And I'm going to replace what's written in the brackets with an x plus 4. So we would get open bracket, and it would be x plus 4 to the power of 2, because I put x plus 4 into here. And then we've got the negative 4, and then open brackets, and it will be x plus 4 like that. Now let's simplify before we do the equating step. So we're going to expand my bracket. So x plus 4 squared means x plus 4 times x plus 4. And then we've got negative 4 multiplying my other bracket. So we're going to get negative 4x. And then negative 4 times positive 4 is negative 16. Now if I expand my brackets here, x times this x would be x squared. Then that x times the 4 would be positive 4x. Then let's move on to my next term in this bracket. So positive 4 times this x is positive 4x. And then finally, the positive 4 times positive 4 gives positive 16. Okay, so that's my brackets expanded. But don't forget about the other two terms there. So the negative 4x and the negative 16. But if we collect like terms, I would have x squared. We've got plus 4x and subtract 4x. So that's going to leave me with positive 4x. And then finally, we have a 16, subtract the 16. So that's going to leave me with 0. So we've ended up with x squared plus 4x once we've simplified that. So that is my final expression for g of x plus 4. So I've successfully completed step 1. We now need to do step 2. And step 2 is to equate my g of x plus 4. So that's this expression here to negative 3, which comes from my equation up here. So I'm going to write that x squared plus 4x is equal to negative 3. And now I have a quadratic equation I need to solve. So to solve a quadratic, we get everything to one side. So one side is 0. So I'm going to add 3 to both sides. So we'd have x squared plus 4x plus 3 is equal to 0. And then one method for solving quadratics is to factorize. So I believe that this would factorize as double brackets and then x and x. And then factors of positive 3 that add to positive 4. Well, that would be positive 3 and positive 1. And that is equal to 0. And now I can figure out which values of x will make my brackets equal to 0. So from the first bracket here, I would get x is equal to negative 3. And for this next bracket, it would be x is equal to negative 1. So those would be my solutions to the equation I was asked to solve. So we've completed step 2, okay, and solved. And those are my solutions. Let's have a look at a harder equation. So this time we've been given two functions. We got f of x and then we got h of x. And then we need to solve this equation here, which looks pretty complicated. Now, the reason it looks quite complicated is because of the function notation. Because of the f of 2x and the h of 2x subtract 3. What I need to do to get this process started is to replace these with something they are equal to. So step 1 to solving this equation is we're going to have to find this function here. We're going to have to find h of 2x subtract 3, like we've been practicing. Then step 2, which could have been my step 1, we need to find f of 2x. And then I can replace the f of 2x with whatever I find. Then step 3 is going to be to do the substitutions. So we're going to substitute by results of 1 and 2 into the equation. And then once we've done that, we can solve to finish off a question. Okay, so let's start with step 1 then. Okay, we're going to start by finding h of 2x subtract 3. So over here, I'm going to write h of 2x subtract 3. So what I need to do is wherever there's an x in h, I need to replace it with a 2x subtract 3. So I'm just going to go to h of x and put brackets around any x's. So this one here. So let's start writing it out. So I'd have the 5 subtract. And then we've got a 4. And then we've got open brackets. And I'm going to replace what's in the brackets with the 2x subtract 3. So I'd have 2x subtract 3 like that. Now let's simplify it because that will likely help me with the solving later on. So we got 5. And then the bracket is being multiplied by negative 4. So we'd have negative 4 times 2x gives me negative 8x. And then we would have the negative 4 times the negative 3 gives me positive 12. And then let's collect like terms. We have a 5 and a 12. So that's going to become 17 subtract 8x. So that is my function h of 2x subtract 3. So what I'm just going to do is I'm going to circle that just to show that I'm going to make use of that later on. So we've completed step 1. So now let's move on to step 2, which is to find f of 2x. So I'm going to write f of 2x, and I'm going to go to the function f of x. And wherever there's an x, I'm going to replace it with a 2x. So let's go to the right-hand side of f of x and just put brackets around any x's. So I'm going to put brackets there. And then let's start writing out my expression. So it's going to be 3, then open brackets. And inside my brackets, I'm going to put the 2x. And then we've also got the subtract 2, like that. Now let's simplify it. So 3 times 2x gives me 6x. And then we got subtract 2. So that is f of 2x. So I'm just going to put a circle around that, like that. So I've now completed step 2. So now we need to move on to step 3, which is substituting into this equation here. So what I'm going to do is I'm going to replace the h of 2x subtract 3 with what I've got written over here. And I'm going to replace the f of 2x with what I've got written down here. So that after I've done this substitution, there will only be terms involving x in there and constant terms. There will be no terms involving any function notation. So you shouldn't see h written there or f written there if you've done things correctly. So let's start writing things out. So let's start step 3 down here. So I'm going to write the 3 outside here. And then I'm going to open a bracket. And I'm going to substitute in my h of 2x subtract 3, which is in this red box over here, which is 17 subtract 8x. So in my bracket, I'm going to put 17 subtract 8x like that. Then I'm going to close my bracket. So I've successfully replaced the h of 2x subtract 3. Now let's focus on the right hand side. So we've got the 13. So I'm just going to write the 13 in. And we've got the plus. And then we've got a 2. So we're going to write that in. And that's multiplying f of 2x. So I'm going to open my bracket. And inside my bracket, I'm going to replace the f of 2x with what it's equal to, which is the 6x subtract 2 down here. So I'm going to write 6x subtract 2 and then close bracket. So now my equation no longer has any function notation in it. Okay, so now it's going to be much easier to solve. So let's start by expanding my brackets. So 3 times 17 would be 51. 3 times negative 8x is negative 24x. And then we got 13. And then the 2 is multiplying the bracket. So we get positive 12x and negative 4. So now it's fully expanded. Let's just simplify each side. So the left-hand side is fine. And then the right-hand side, I can collect like terms. 13 subtract 4 is 9. So we have 9 plus 12x. And then let's get our x all to one side. So I'm going to add 24x to both sides to get all my x to the right-hand side. So that would leave me with 51 on the left-hand side. On the right-hand side, we'd have the 9. And then 12x plus 24x gives me 36x. And then we've got all the x to one side. So now we need to remove this 9 here. So I'm going to subtract 9 from both sides. So that would leave me with 42 is equal to 36x. And then we could divide by the 36. So we're going to get x is equal to 42 over 36, which I can simplify because there's a common factor of 6. So x is going to be equal to 7 over 6. And that is the solution to my equation. If I was to substitute that value into this equation here, both sides would be equal to each other. So we're now going to look at composite functions. So the definition is here. A composite function is a function that depends on another function, and it is created when one function is substituted into another function. You can also substitute a function into itself. That's fine. That will give a composite function. So let's start thinking about the notation. Let's say you have some function f of x, and then you have some other function g of x. One composite function I could create by using both of these would be written as follows. And how we'd say that out loud is we would say f of g of x, like that. Or you could say fg of x, like that. And in this scenario, you'd be substituting the g, the right-hand function, into the left-hand function f. Okay, so you might refer to g as the inner function. So you substitute your inner function, which is written on the right, into your outer function. Now, some other notation we could use, which I think is a little bit clearer as to what you need to do. You could write f, and then you could open brackets, and then write the next inner function. So g of x, like that. Okay, so that means the exact same thing, but it's very clear that you're going to substitute g of x into f of x. Now, just to be clear, the f and g are not multiplying each other. Okay, they're being composed. Now, there is another composite function we could have got out of using these two functions. What we could have written instead was a g followed by an f, like this, and this would be called g of f of x. So g of f of x, or you could write gf of x, like that. Now, in this scenario, you'd be substituting f of x into g of x. So you could write this as g, then open brackets, f of x, like that, which makes it a bit clearer that you need to substitute the f of x into the g of x. Now, you can use more than two functions. Okay, that's fine. You can have more complicated ones, which look g, f, h of x if you have another function. And as I said, you can use the same function twice, so I could put a f in place of the h, so we'd have gff of x. But we'll mainly be considering when we're composing with two functions. Now, just to be clear, because the g and f are not being multiplied, do not ever assume that gf of x is going to be equal to fg of x. There might be the odd scenario where they do come out equal, but in general, they are not the same. So please don't treat them as the same. So now let's have a go at actually finding some composite functions. So it says the functions f of x and g of x are defined here. So we've got the function f of x and the function g of x. Now the first composite function we need to find is fg of x. So what I'm going to start by doing is rewriting this in my preferred notation. I am going to put brackets around the g of x, my inner function. So I'm going to write f and then open brackets and then write out the rest of the statement, which is g of x, and then close brackets. Because this makes it very clear I need to substitute g of x into f of x. So what I'm going to start by doing is, in place of the g of x here, I am going to write what g of x is equal to, which is the 2x squared plus 3x take 5. So I'm going to write the f, then open brackets, then I'm going to write in my expression for g of x, which is the 2x squared plus 3x subtract 5, and then I'm going to close my bracket like that. Okay, because now it's very clear what I need to do. Wherever there's an x in the f of x, I need to replace it with 2x squared plus 3x take 5. So that's what I'm going to do. I'm going to write equals to, and I'm going to start writing out my function f of x. So we've got a 5, and then that multiplies x. Now I'm going to put brackets around my x, because what I'm going to do is replace what is inside the brackets with the underlined part here. So the 2x squared plus 3x take 5. So I'm going to open brackets, and then it's going to be 2x squared plus 3x, subtract 5, close brackets, and then I'm going to have to write in the negative 3. So I'm going to have a subtract 3 here. Now let's simplify it. So if we expand my brackets, I would get 10x squared plus 15x, subtract 25. So I've multiplied all three terms by the 5 outside the bracket, and then we still got the subtract 3, which is not being multiplied by 5. Then we can simplify and we get 10x squared plus 15x, and then negative 25 subtract 3 is negative 28. So that would be my function fg of x. So now let's have a go at finding my next composite function, which is gf of x. Okay, so I'm going to write it in my preferred notation, which is to put brackets around my inner function. So I'm going to write g, open brackets, f of x, like that. Then the idea is I need to substitute f of x into g of x. So in place of the f of x here, I'm going to write in what f of x is equal to, which is the 5x subtract 3. So I'm going to write equals to g, open bracket, and then I'm going to write in the 5x subtract 3. So what I have to do to find this composite function, I need to substitute 5x subtract 3 in any x's in g of x. So what I'm going to do is go to g of x, and I'm going to put brackets around any of the x's. So I'm going to put a bracket there like that, and a bracket there like that. Okay, and I'm going to replace all the x's in those brackets with the 5x subtract 3. So I'm going to write equals to, and I'm going to start writing out my expression for g of x. So we got a 2, then open brackets, and inside the bracket, I'm going to put the 5x subtract 3. And that is raised to the power of 2. Then we got the plus 3, which I'm going to write out next. And then open brackets, and then I'm going to write in my 5x subtract 3. And then I got my subtract 5 at the end. So that is my composite function. I can then go through and simplify it. So if I was simplifying, I need to expand these brackets. So we'd have 2 lots of, and it would be 5x subtract 3 multiplied by 5x subtract 3, like that, because we're squaring the 5x subtract 3. Then we got a positive 3 multiplying this bracket, so we get positive 15x for 3 times 5x. And then from the 3 times negative 3, we get negative 9. And then we got to subtract 5 like that. Now let's expand these brackets here. So then what I'm going to do is write my 2 and an open bracket, and anything I get from this expansion I'm going to write in this bracket. So we've got 5x times 5x, which is 25x squared. And then the 5x times negative 3, which gives me negative 15x. And then moving on to my next term, we've got negative 3 multiplied by the 5x, which gives me negative 15x. And then the negative 3 times the negative 3, which is positive 9. Close bracket, and everything's going to be multiplied by 2. Then write out the rest of my terms, so plus 15x. And then we've got the subtract 9, subtract 5, like that. Now let's multiply out this bigger bracket. So 2 times 25x squared is 50x squared. Then we've got negative 15x subtract 15x, which is negative 30x, which if I multiply by 2 is negative 60x. And then the 2 multiplied by 9 gives me positive 18. And then we're going to write out the rest of my terms. So we've got plus 15x, subtract 9, subtract 5. Now let's collect like terms. So we've got 50x squared. And then negative 60x plus 15x gives me negative 45x. And then the positive 18, subtract 9, subtract 5. So that's going to give me a final constant of positive 4. And that would be my composite function gf of x. Okay, so the final composite function I'm going to find using our f of x and our g of x is f of x. So actually, I'm not going to use the g of x. I'm just going to have to use f. Now, just to be clear, this f of x could be written as f squared of x like that. However, this is not equal to f of x to the power of 2 like this. Okay, we are not squaring f of x. If I wish to find this one here, all I need to do is take my expression for f of x, which is 5x subtract 3, and then put it in brackets and square it. That is not what I'm being asked to find. This is something different. This is not a composite function. Okay, I need to find the composite function f of x, which could be written like this. However, this here is my composite function notation, not squaring in the usual way that you are used to. So let's just take this off and let's have a go at finding f of x. So what I'm going to do is put brackets around my inner function. Okay, so I'm going to write this as f and then open brackets f of x. And then what I'm going to do is replace the f of x here with what f of x is equal to. So replace my inner function with a 5x subtract 3. So I'd have f of 5x subtract 3 like that. So in order to find this composite function, I need to go to f of x and I need to replace all of the x's with a 5x subtract 3. So I'm going to go to my function of fx and put brackets around all of the x's. So I'm going to put a bracket here and a bracket there. And then inside that bracket, I'm going to replace the x with the 5x subtract 3. So let's start writing it out. So we got the 5 first, and then open bracket. And in that bracket, I'm going to put the 5x subtract 3, my inner function. And then close bracket, and then we got the negative 3 like that. Then let's simplify it. We'll expand our bracket to 25x subtract 15 when I multiply everything in the bracket by 5. And then we got the negative 3. But simplifying further, we get 25x, and it's going to be subtract 18. And that is how I'd find f of x. So we're now going to look at how we can evaluate a composite function for a specific value of x, or whatever your variable is. So we're given 2 functions, h of x and g of x, and we need to find gh of 3. So you can see here in the brackets, we don't have x written there. We now have a specific numerical value written in there, which is 3. So there are 2 methods for which we can obtain the answer. Okay, so let's start with method 1. So method 1 involves finding the composite function gh(x) as our step 1. So we're going to find gh of x. And then once we found that, we're going to substitute the value 3 into our function gh of x. So we are going to sub 3 into gh of x. Okay, so this is method 1. So let's start with finding gh of x. So step 1, we're going to write gh of x. Now I prefer the notation where the in function h is in brackets like this. And what I'm going to do is replace the h of x with what it's equal to. So h of x is equal to x squared. So I'm going to put an x squared in the bracket so we get g of x squared. So in order to find this composite function, I need to substitute x squared in for x in g of x. Okay, so I'm going to write out this expression for g of x, but in place of this x here, I'm going to replace it with an x squared. So I would get x squared plus 4 like that. And that is the function gh of x. So that is step 1 complete. We now need to do step 2. So step 2 says substitute our value 3, which is the value over here, into gh of x. Okay, so I want to find gh of 3. So replace the x here with a 3. And to do that, I would have to substitute 3 into the right-hand side in place of x. So we would get 3 squared plus 4. Now 3 squared is 9, plus 4 is 13. So that would be my final answer using method 1. Now we're going to consider an alternative method. Okay, so I'll call this method 2. And method 2 is in most circumstances a bit quicker. So what we're going to do in method 2 is we are going to rewrite the gh of 3 as g and then open brackets h of 3. So the idea is we need to substitute h of 3 into gx. So step 1 is going to be to find h of 3. And then step 2, once I have found the value of h of 3, so what's in my brackets, I'm then going to substitute that into g of x, which is my outer function here. So then I'm going to sub h of 3 into g of x. So let's carry out my steps. So step 1, we need to find h of 3. So in order to do this, I'm going to substitute a 3 in place of x in h of x. Okay, so I'm going to replace this x with a 3. So I would get 3 squared is equal to 9. Okay, so that is step 1 done. Let's now move on to step 2, which says I'm going to substitute h of 3, which is equal to 9. So essentially I'm going to substitute 9 into g of x. If I'm substituting 9 into g of x, I am finding g of 9, like that. And in order to find that, I need to substitute 9 in for x in g of x. So what I'm going to do is in the x plus 4, I'm going to replace the x with a 9. So I'd have 9 plus the 4. And of course, that comes out as 13 again. So I get the exact same answer that I had up here. So both methods work. It's up to you which one you want to do. However, I'm going to go through the second method again, okay, for a different calculation. So let's just clear off this. So if we look at our second one, we have hg of negative 7. Okay, so I'm going to write hg of negative 7 down here. Now, if we're doing the second method, step 1, I'm going to write brackets around my inner function, and that is what I need to find. Okay, I need to find what is written in those brackets, which is g of negative 7. Now, step 2 involves taking my g of negative 7 and substituting it into my outer function h. So I'm going to sub g of negative 7 into h of x. So let's do my steps then. So let's start with step 1. So that is to find g of negative 7. So I'm going to write g of negative 7. And wherever there's an x in g of x, I'm going to replace it with negative 7. So in this expression here, we would get negative 7 plus 4. And that is, of course, equal to negative 3. Okay, so that is step 1 done. We now need to do step 2, which is to substitute g negative 7, which is equal to negative 3, into h of x. So if I'm substituting negative 3 into h of x, what I'm doing is I'm finding h of negative 3 like that. And then to find this, I'm then going to substitute this negative 3 in for x in h of x. Okay, so I'm going to write negative 3 and I need to square it. Now, because it's a negative value, I need to put it in brackets and write to the power of 2 like that. So then I would end up with negative 3 times negative 3, which is positive 9, which is my final answer to the question. So I have found that hg of negative 7 is equal to 9. So we're now going to look at inverse functions, and we got the definition of an inverse function here. Okay, it says the inverse of a function f of x is the function that has the opposite or reverse effect of the original function and is written with this notation here, f minus 1 of x. Now, just to be clear, when we've got the negative 1 up here, this is not a power. So previously, you might have learned that a negative 1 power means reciprocal. So you might start thinking that this is the same as 1 over f of x. That is not correct. This notation here is just the notation we use for an inverse function. So don't mix up the two. Now what we're going to consider is how do we actually find an inverse function? So we've got f of x is equal to 4x subtract 2. Well, let's think about what's happening to x. We're starting with x. Then we've got 4x, so that means we are multiplying by 4. So I'm going to write multiply by 4. And then we are going to subtract 2. So once we multiply by 4, we've got 4x. We then subtract 2 to get our final result, which is 4x subtract 2. Our inverse function is going to do the inverse of this. Okay, so we are going to start on this side going this way. And instead of subtracting by 2, the inverse of that is adding 2. So we are going to add 2. So let's start with x on this side. We're going to add 2. And then that's going to give me x plus 2. And then going back this way to get back to where we started, where instead of multiplying by 4, we're going to do the inverse, which is of course dividing by 4. So in terms of how I'd write my final function, it will be the x plus 2 that I've got there. And then I'm going to divide that by 4. So I'm going to write it with a denominator of 4 like that. So now we can write out our inverse function. It would be that the inverse of f of x is equal to, and it's going to be x plus 2 over 4 like that. And that would be my final answer. So to investigate further, I'm going to consider the composite function f minus 1 of f of x like this. So inverse f of x is how I could say that out loud. So this is a composite function. Using my preferred notation, we could write it as inverse f, and I'm going to put brackets around this part. So we'd have open brackets, f of x like that. That is the function I want to find. So in order to do this, what I have to do is take f of x and substitute it into my inverse. So inside the brackets here, I'm going to replace f of x with the 4x subtract 2 it's equal to. So I have equals to inverse f of 4x subtract 2. And now what I have to do is go to inverse f, which is over here, and wherever there is an x, I'm going to replace it with 4x subtract 2. Okay, and the only place x appears is in the numerator here, so I need to replace that x with a 4x subtract 2. So equals to, we'd write my fraction. In place of that x I circled, we're going to put the 4x subtract 2. And then we've got the plus 2. And then we've got to divide by 4, like that. Now let's simplify. If we simplify my numerator, well, negative 2 and plus 2 just comes 0, so we're left with 4x over 4. And if we simplify that further, there's a common factor of 4, so we're just left with x. So if we do the inverse of f of x, we would just get x as our final answer. So what is this actually showing? Well, if we substitute x into this composite function, our end result is still x. We haven't actually changed the value of x when we put it through the functions, because the idea is the inverse function is going to cancel out the impact of the f of x. And the same would happen in reverse. So if I found f of the inverse of f of x, okay, I would also get x as my result, and you could try and work that through. Now let's consider this with a numerical example. So I've got my function f of x and its inverse that we found here. What we're going to do is let's substitute a value into them. Okay, so let's start with f of x. We're going to find f of 3. So to find f of 3, wherever there's an x in f of x, I'm going to replace it with a 3. So the only x is this one here, so I'm just going to put brackets around it. So we would have 4, open brackets, 3, close bracket, subtract 2. And if I was to simplify this calculation, we get 12 from 4 times 3, and then subtract 2, we end up with 10. Now what I'm going to do is substitute this 10 into an inverse function. So we're going to calculate inverse f of 10 like that. So wherever there's an x in my inverse function, I'm going to replace it with a 10. Okay, so the only x that is here, so I'm going to have 10 plus 2 divided by 4. So if we calculate this, my numerator is 12. If I divide by 4, I end up with 3. Now if we investigate what's happened here, if we look back at the start of our working when we did f of 3, this 3 here is our input into f of x. Okay, and then this 10 over here was my output of f of x. But if we consider what's happened with our inverse function, well, this 10 here was my input. And then if we look at my output, I've ended up with 3. So essentially what has happened is the inputs and the outputs have swapped around. Because 3 was the input for f of x, but it was the output for our inverse. And then 10 was our output for f of x, 10 was our input for our inverse. So the inputs and outputs swap for your function and its inverse. And as you can see, the function is undone by the inverse, so we've just ended up with 3 again, which supports this statement up here. The idea, if we substitute an x value into f of x, and then substitute the result into our inverse, then we're just going to end up with our initial x value. So that's what an inverse function is. Now let's try and find an inverse function in some more complex scenarios. So we're now going to look at a direct method for finding inverse functions that doesn't involve writing out some sort of flow diagram. So let's make use of the key facts we've just been discussing. The idea that for our function and its inverse, the inputs and our outputs are swapped. Okay, because this is going to be key to the method I'm about to go through. Now remember, our inputs are our x values. Okay, so I'm just going to write an x above here. And then our outputs, well, they're our f of x values. They're what f of x is equal to. So I'm going to write f of x here, like that. Now, in order to get this process started, what I'm going to start by doing is replacing the f of x with a y. Because f of x essentially takes the place of y with what we're used to. But we're also going to end up rearranging the equation, and it's going to be much easier to do that if you've got a y in there instead of the f of x notation, which might confuse you. So step 1, we're just going to replace f of x with a y like that. Okay, and then write out the rest of my equation, 4x subtract 2. Now let's make use of this key fact here. So inputs and outputs are swapped. So our inputs are x, and our outputs are essentially f of x, which we've defined as y. So what we're going to do to get this process started, we're going to swap all of the x's and y's around. So wherever there's a y in this equation, I'm going to write an x. Wherever there's an x, I'm going to write a y. Okay, so this y here is going to be replaced with an x. And then the 4 stays, and then this x is going to be replaced with a y like this. And then subtract 2. And we're doing that because the roles of the x's and the y's have essentially swapped. Now our next step is to make y the subject of my equation. Okay, we're going to get y on its own on one side because I still want y to be my output in this swapped up scenario. So I'm going to add 2 to both sides. So I'm going to get x plus 2 is equal to 4y. And then I'm going to divide by 4 on both sides. So I would get x plus 2 over 4 is equal to y. And this here is going to be my inverse function, and you might remember it from when I went through the flow diagram method. However, the last thing I have to do is just replace the y with our function notation, okay? Because this is going to be my inverse function. So in place of the y, I'm going to write my inverse function notation. So we would get that the inverse of f of x is equal to the x plus 2 over 4. Okay, and that is how we find an inverse function using a more direct method than our flow diagram. Now, the flow diagram will work nicely in some more straightforward scenarios like this one. However, as the equations get more complex, you're going to definitely want to do this method. So let's start looking at some harder ones. So we've got another question here. We're finding the inverse function of f of x. So what I'm going to start by doing is replacing the f of x with a y. So we've got y is equal to 3 lots of x over 2 plus 4. Then our next step is to swap our x's and y's around because in our inverse function, the inputs and outputs have swapped. So wherever there's a y, I'm going to replace it with an x. And wherever there's an x, which is here, I'm going to replace it with a y. The rest of the statement stays the same, like this. Now we need to make y the subject. There's a few ways you could do this. You could start by expanding the brackets, but I'm not going to do that. I'm going to start by dividing by 3 because that's multiplying the bracket. So divide by 3 on both sides. So we get x over 3 is equal to, this 3 is cancelled out. So we're just left with the bracket, which is y over 2 plus 4. But next I'm going to subtract 4 from both sides. So subtract 4. So we get x over 3. Subtract 4 is equal to y over 2. Now to finish this off, we just need to multiply by 2 on both sides. So I'm going to multiply by 2 to cancel out this 2 here. Multiply by 2. So the easiest way to write it is 2, open bracket, x over 3, subtract 4, and that is equal to y. So we found our expression for our inverse function. We now just need to write it out using our notation. So I'm going to write the inverse of f of x, okay, instead of y, is equal to what we've circled. So 2 lots of x over 3, subtract 4. If our function was defined using a different letter, so if it was defined initially with a g, then we'd write a g and then a -1 instead. Okay, so the letter that the function is defined by does not matter. Let's have a look at an even harder question. So here's our question here. Our function f of x is fraction. Okay, and as you can see, x now appears multiple times, which is going to make this a bit trickier. And we need to find the inverse of f of x. So let's start our process by replacing the f of x with a y. So we get y is equal to 4x plus 3 divided by 2x plus 5. Like that. Now what I'm going to do is replace all the y's with an x. So we're going to get x is equal to, and I'm going to replace all of the x's with a y. So this x here and that x there. So we would get 4y plus 3 divided by 2y plus 5. So now we need to rearrange to make y the subject. So the first thing I'm going to do is try and get y out of my denominator. So to remove the denominator of my fraction, I need to multiply by it. So I'm going to multiply by 2y plus 5 on both sides. So times 2y plus 5. We should put it in brackets technically because it's multiple terms. So on the left-hand side, we've got our x, and it's going to be multiplied by 2y plus 5. And then on my right-hand side, the denominator is cancelled out. So we're just left with the numerator of 4y plus 3 like that. Now the next thing I'm going to do is expand my brackets on the left-hand side. So multiplying by x, we get 2xy plus 5x. And then the right-hand side is going to stay as it is. Now I want to make y the subject. So I'm going to have to get all of the terms involving y to one side. So that's this term here and this term here. It doesn't matter which side. So let's move on to the right-hand side. So I need to remove the 2xy by subtracting 2xy on both sides. Then that leaves me with 5x on the left-hand side, and then we'd have 4y plus 3 subtract 2xy on the right-hand side. So I've got all my terms involving y to one side. I now have to remove all the terms not involving y, so that's the plus 3. So we're going to subtract 3 from both sides. So I would get 5x subtract 3 is equal to, and it will be 4y subtract 2xy. Okay, so now we're in a good position, but the problem is y appears twice. I only want it to appear once, so we're going to have to factorize y out because it's a common factor. So I'd have y, open brackets, the 4, and then the -2x, like that. And the left-hand side stays as it is. So the y is being multiplied by 4 subtract 2x, so I'm going to divide by 4 subtract 2x on both sides. So that's going to cancel out the bracket here to leave just y. And then on my other side, the 5x take 3 is the numerator. And what we've divided by, the 4 subtract 2x, is my denominator. So now we can write out our function, our inverse function, using the notation we have learnt. So I'm going to replace the y with our inverse function notation. So f minus 1 of x is equal to 5x subtract 3 over 4 subtract 2x. So this is the type of question where using a flow diagram method is just not going to work. You're going to have to rearrange like this. Now let's look at solving some equations involving inverse functions. So here's our question. We're given that g of x is equal to x subtract 5 over 3. And we're asked to solve this equation here. So what does that equation actually say? Well, it says that the inverse g of 2x is equal to 23. So when you're being asked to solve it, we're being asked to find the value of x such that if you multiply that value of x by 2, and then substituted the result into inverse g of x, we would get an output of 23. So in order to solve this equation, I'm going to want to rewrite the left-hand side over here so that our function notation is no longer present. I want to replace the inverse g of 2x with some expression that doesn't involve our function notation. So therefore, I'm going to have to find what inverse g of 2x actually is equal to. So to start that process, step 1 is going to be to find inverse g of x. Then once I've found that, I can then replace the x with a 2x instead, which is then going to find me inverse g of 2x. So step 2 is to find inverse g of 2x. And then my final step is to equate that to the 23 and solve. So step 3 is equate step 2 to 23 and solve. And then I should get my solution for x. So let's get started with our step 1. Okay, to do that, I'm going to have to return to g of x over here. Okay, and we're going to have to find the inverse of it. So I'm going to replace the g of x with a y. So we get y is equal to x subtract 5 divided by 3. And then what I'm going to do is swap the y's out for x's and swap the x's for y's. So this y over here is going to become an x. And then on the right hand side, this x up here is going to become a y. And then we will get subtract 5 over 3. Then we're going to rearrange to make y the subject. So we'd multiply by 3 on both sides. So we would get 3x is equal to y subtract 5. And then we're going to add 5 to both sides. So we would get 3x plus 5 is equal to y. So then I've got my inverse function. It's the 3x plus 5. But let's write it using our inverse function notation. I would say that g minus 1 of x is equal to 3x plus 5. So that means that I've completed step 1. We now need to move on to step 2, which is finding inverse g of 2x. So in order to do that, I have to go to inverse g of x, and I'm going to replace the x here with a 2x. So I would get inverse g of 2x, and to find the expression for it, I'd have to go to the right-hand side of inverse g of x and replace all of the x's, so this x here, with a 2x. Okay, so I would get 3 multiplied by 2x and then plus 5, like that. And then let's simplify, as it's probably going to be helpful for later on. 3 times 2x is equal to 6x. So we've got 6x plus 5. So that would be step 2 complete. Now let's move on to step 3, which is to equate what we found in step 2, so that's the 6x plus 5 down here, to 23 and solve. So we're making direct use of the equation we're being asked to solve in the question. Okay, so our inverse g of 2x is equal to 6x plus 5, and that has to be equal to 23. And now I have a simple linear equation to solve. I'm going to subtract 5 from both sides. So we get 6x is equal to 18. And then we just need to divide by 6 on both sides. So we would get that x is equal to 3. And that is the solution to the equation we were being asked to solve. So if I was to substitute x equals 3 into the inverse g of 2 of x, I would get 23. Now I do just want to discuss a different method, which would have been a bit faster for this question, using our definition of an inverse function. So if we have a look at the equation we were being asked to solve here, okay, the 2x, that is the input into my inverse function. Okay, that's what's being substituted in. And then the 23, that's my output. Okay, that's what I get out after I've substituted the 2x in. Now, the relationship between a function and its inverse is that the inputs and the outputs swap. Okay, therefore, I could rewrite this equation where the 23 is the input into the original function g of x, and the 2x is the output. So what I could write is that our original function g of 23 would be equal to 2x. Okay, so now that we're using g, the 23 is now my input rather than my output, and the 2x is my output rather than my input. And this equation here would actually be much quicker to solve, because the only function notation I have present in it is the g of 23, which I'm going to need to replace. And to calculate g of 23, all I need to do is substitute the 23 in for the x in g of x. So let's do that. Okay, if we substitute the 23 in, we'd have to replace this x in the numerator with 23. So I would get 23 subtract 5 divided by 3 is equal to 2x. And now I have a fairly straightforward equation that I can solve for x. 23 subtract 5 is 18. 18 divided by 3 is 6. So we get left with 6 is equal to 2x. And then we just have to divide by 2 on both sides. And we would get that x is equal to 3, which is the same answer that I got with the other method down here. But as you can see, we got my answer a lot quicker. However, that won't necessarily always be the case. If the original equation was a bit more complicated, for example, inverse g of 2x is equal to, say, 23 plus 5x, so we had another term in our equation involving x, then this second method won't be as much quicker, because if I was to rewrite this equation here without our inverse function, we would write that 2x is equal to g of 23 plus 5x. So therefore, I'd need to find the function g of 23 plus 5x, which is a bit trickier than just finding g of 23. So therefore, the second method would take a little bit longer with this second equation I've written out here. And for even more complicated equations, you might find you have to work it through like I did with the original method. Now let's have a look at an even more challenging question involving inverse functions and equations. So this is our question here. This time we're given two functions. We've got f of x is equal to 5x plus 3, and g of x is equal to ax plus b, and we're told that a and b are constants, so they're fixed numerical values. Now we're given two bits of information about our functions. G of 3 is equal to 20, and inverse f of 33 is equal to g of 1. So I'm guessing we're going to have to use that at some point. So we need to find the values of a and b. Now to do that, we're going to have to form equations using these two bits of information here. So let's start with the g of 3 is equal to 20. So this means that when I substitute 3 in for x in g of x, the result should be 20. So let's do that. Let's go to the right-hand side of g of x. Again, I'm going to replace the 1x that there is there with a 3. So I would get a multiplied by 3 plus b, and that should be equal to this 20 here. Let's simplify my equation. So a times 3 is 3a. So 3a plus b is equal to 20. So I have an equation linking a and b together. However, because there are two unknowns in that equation, I'm not going to be able to figure out a and b just by using it. We're going to need another equation. So we are going to have to use this other bit of information over here. Okay, the inverse f of 33 is equal to g of 1. So what we have to do is find the inverse of 33, find g of 1, and we're going to have to equate them. Okay, so step 1, I'm going to say, is find g of 1. Step 2, we're going to find the inverse of 33. However, to do that, I have to find inverse of f of x first. So actually, my step 2 is going to be to find the inverse of f of x. And then step 3 will be then to find the inverse of 33 by substituting 33 in for x. And then step 4, we are going to equate what we found in step 1 and what we found in step 3. Okay, and that's going to give me an equation I can then use with the 3a plus b equals 20 to figure out what a and b are. So let's start with step 1, which is finding g of 1. So I'm just going to write g of 1 over here. And in order to find g of 1, what I'm going to do is go to g of x and replace the x with 1. So I would get a multiplied by 1 plus b, which would then simplify to just a plus b, since a times 1 is just a. So that is step 1 done. Now let's do step 2. So step 2 is finding the inverse of f of x. Okay, so let's write f of x, which is this function here at the bottom. And to find the inverse, we start by replacing f of x with y. So we get y is equal to 5x plus 3. Then what we're going to do is replace all our y's with x's and all our x's with y's. So this y would become an x, and then this x would become a y like that. We're now going to rearrange to make y the subject. So I'm going to subtract 3 from both sides. So x subtract 3 is equal to 5y. And then we're going to divide by 5, which is going to give me y is equal to x subtract 3 over 5 like that. So then the final thing we're going to do is replace this y here with our inverse function notation. So I would get the inverse of f of x is equal to x subtract 3 over 5 like that. And that is step 2 complete. We're now going to have to do step 3, which is finding the inverse of 33. So I need to substitute 33 in for x. So step 3, and we're going to find the inverse of 33. So I have to go to my inverse function and replace the x with a 33. So we'd have 33 subtract 3 divided by 5. So on the numerator we get 30, divided by 5 we get 6. Okay, so that is step 3 done. Now we can move on to step 4. So step 4 says we're going to equate what we found in step 1, so g of 1, which is written all the way over here. And we're going to equate that with what we found in step 3, which was the inverse f of 33, which is written down here. So when we do step 4, we're going to equate those underlined parts. So a plus b is equal to 6. So we've successfully made use of this bit of information here by equating those two things we found. What we now have is another equation linking a and b together. So I'm just going to circle that. Now my other equation linking a and b together was this one up here. So we're now going to have to solve them simultaneously. So what I'm going to do is write the 3a plus b down here. And that's equal to 20. Now let's try and eliminate a or b. So what I notice is that I have the same amount of b in both equations. So I can subtract. And when I do that, I get a subtract 3a is negative 2a. B subtract b is 0b. And then 6 subtract 20 is negative 14. I can then divide by negative 2 on both sides. So I'd have a is equal to negative 14 divided by negative 2 is positive 7. So I've got my value for a. We now just need to substitute this value into one of my two simultaneous equations. So we're going to do the top one in order to find b. Okay, so in place of the a, we're going to put 7. And then we plus b is equal to 6. So if I rearrange, we subtract 7. So we get b is equal to negative 1. So a equals 7 and b equals negative 1 would be my final answer. So we're now going to look at some more challenging problems involving both composite functions and inverse functions. So here's our question. We've been given two functions, f of x and g of x up here, and we've been given an equation to solve. So we have f of x is equal to the inverse function of g. So we need to find the value of x that makes this statement true. So essentially the value of x that will make f of x equal to the inverse of g of x. So there are essentially two first steps I'm going to need to do. Step 1 is I'm going to need to find f of x because I want to replace that with something that doesn't involve the function notation. So I need to find f of x, which is a composite function. And step 2, I need to find the inverse function of g. So I need to find inverse g. And in step 3, I'm going to equate what I found in step 1 and step 2. So I'm going to equate 1 and 2, and then we'll be in position to solve because we'll no longer have any function notation in my equation. So let's get started with step 1. So finding f of x, so we're only using f of x for this step here. Okay, and another way of writing f of x, that makes it a bit clearer what we need to do. I'm going to put brackets around my inner f like that. Okay, so I'd have f, open brackets, f of x like that. So clearly what I need to do is substitute f of x into f. Okay, so I'm going to replace the f of x here with what it's equal to, which is the 3x subtract 2. So I would have f of 3x take 2. And then it's very clear what I need to do. I need to substitute 3x take 2 into f of x. So wherever there's an x in f of x, I'm going to replace it with a 3x subtract 2. So I'm just going to put brackets around all the x's. So there'll be a bracket here and a bracket there like that. And that's my only x. So let's start writing out my function. But in that bracket, I'm going to put 3x take 2. So we'd have 3, open bracket, 3x subtract 2, close bracket, subtract 2. Then we're going to simplify because that's probably going to help me later on when I do step 3. So expanding my brackets, 3 times 3x, 9x, 3 times negative 2 is negative 6. And then we got to subtract 2. And simplifying further, we get 9x subtract 8. Okay, so that is f of x. So that is step 1 complete. And we're going to make use of that later. So I'm just going to circle it like that. Right, let's move on to step 2. Now, step 2 is finding the inverse function of g. So I'm going to write g of x down here because this is the only function I'm going to use in step 2. And let's do the process of finding an inverse function. I'm going to replace the g of x with a y just to help with rearranging. And then what we need to do is replace all of the y's with x's. So we'd have x equals 2. And I'm going to replace all of the x's with y's. So we'd have the square root of 2 subtract y like that. Now we're going to rearrange to make y subject. So to undo the square root, we're going to have to square both sides. So we'd get x squared is equal to 2 subtract y, because squaring is the inverse of square rooting. And then to make y the subject, I'm going to subtract the 2 to the other side. So we get x squared, take 2 is equal to negative y. But I don't want negative y, I want positive y. So I need to multiply by negative 1 on both sides. So y is equal to negative x squared plus 2 like that. Then I've pretty much found my inverse function. I just need to replace the y with the inverse function notation. Okay, in this case, that would be the inverse of g of x. So we're going to write inverse g of x is equal to negative x squared plus 2. Okay, so that is step 2 complete. So I'm just going to put a tick here. And now we can move on to step 3. So step 3 says I need to equate what I found in step 1 and step 2. Okay, what I found in step 1 and step 2 are circled in red. Okay, I found f of x, the left-hand side of the equation down here. And I found the right-hand side of the equation, inverse g of x, down here. So I just need to equate the two. So I'm going to write step 3. And then we're going to write the 9x subtract 8 is equal to the negative x squared plus 2 like this. Now I've got myself a quadratic equation I need to solve to get myself the final answer. Okay, so what I'm going to do is get everything to one side. So I'm going to make the x squared positive because I prefer that. So I'm going to add x squared to both sides. So the left-hand side would be positive x squared plus 9x subtract 8 is equal to the 2 left over. And then we're going to subtract 2 from both sides. So we get x squared plus 9x subtract 10 is equal to 0. So then we've got to solve this quadratic. So you could use factorizing, completing the square on the quadratic formula. Now I believe that this one here factorizes quite nicely. Okay, there's no common factor other than 1, so it's going to be double brackets. And because it's 1x squared, it's going to be x and x. Then factors of negative 10 that add to positive 9. Well, that is going to be positive 10 and negative 1 is equal to 0. Then the x values that are going to make my bracket 0, for this one would be x equals 1. And for my other bracket, it will be x is equal to negative 10. So my final solutions would be these two x values here. They are the ones that I can substitute into my initial equation and get the left-hand side equaling the right-hand side. Let's have a look at another question. So here's our question. We're given a function f of x and a function g of x. And we are told that this calculation here simplifies into a quadratic format. We need to work out the values of what a, b, and c in that quadratic are going to be. Okay, so I'm going to initially focus on this expression here. Okay, so we've got the inverse of f of x, and we have the composite function gf of x. So I need to start by finding those two there. So step 1 is going to be to find the inverse of f of x. So step 1 is find inverse of f of x. Then step 2 is going to be to find this composite function here. So we're going to find gf of x. And step 3, we're going to add them together. So we're going to add our result of step 1 and step 2. And then we just need to make sure it simplifies into this format here, which is essentially going to be step 4. But let's focus on these first 3 steps. So step 1, we need to find our inverse of f of x. So I'm going to write f of x down here. F of x is equal to 2 subtract x over 3. So let's replace the f of x with a y. So we would get y is equal to 2 subtract x over 3. Then we're going to replace all my y's with x's. So we'd have x is equal to and we're going to replace all my x's with y's. So we get 2 subtract y over 3. Let's rearrange to make y the subject. So we're going to times by 3 to get 3x is equal to 2 subtract y. Then we're going to subtract 2, so we would get 3x subtract 2 is equal to negative y, and then multiply by negative 1. So we would get positive y is equal to negative 3x plus 2, like that. Then we just need to replace the y with the inverse function notation. So we're going to write inverse f of x is equal to negative 3x plus 2. Okay, so that is step 1 complete. So I'm just going to circle that as we're going to make use of that later on. So now let's move on to step 2. So step 2 is to find gf of x, which is a composite function. I'm going to write it in my preferred notation, which is g, open brackets, f of x. And then I'm going to replace the f of x in here with what it's equal to, because the idea is I need to substitute f of x into g of x. So I'm going to write g, open brackets, and then I'm going to put in 2 subtract x over 3, like this. So what I need to do is substitute this expression into g of x. So wherever there's an x in g of x, I'm going to replace it with 2 subtract x over 3. So let's put brackets around all my x's in g of x. So I put a bracket here and a bracket there, and then a bracket here and a bracket there. So I would get 18, open brackets. I'm going to put this fraction here in. So 2 subtract x over 3, close bracket. And then we need to put our power, which is squaring. So I'm going to write a squared out here. And then we've got plus 15, open brackets, and then we're going to put this fraction in for x. So 2 subtract x over 3, like that. Okay, so we have an expression for gf of x. However, I am going to simplify it first. Okay, because we're going to have to end up with ax squared plus bx plus c. So let's get this into a more favourable format. So what I'm going to do is, if we're squaring a fraction, we're squaring our numerator and denominator. So I'm going to rewrite this as 2 subtract x to the power of 2. So we're squaring my numerator, and then our denominator would be 3 squared, like that. I'm going to close my bracket. Then for my other fraction, this 15 is essentially 15 over 1. So the 1 multiplies the 3, so we keep the 3 on the denominator. But then the 15 will multiply the numerator. So we'd have 15 times 2, which is 30, and 15 times negative x, which is negative 15x, like that. Okay, and now what we're going to do next is expand the brackets on my first fraction in full. So we'd have 18, and then we just need to think about, what does 2 subtract x squared mean? Well, it means 2 subtract x times 2 subtract x. And then my denominator is 3 squared, which is 9. And then we'll close my bracket. And then for this second fraction, well, there's a common factor of 3 between the numerator and denominator. Okay, because both 30 and the negative 15 are divisible by 3. So 30 divided by 3 is 10. Negative 15x divided by 3 is negative 5x, like that. Now let's finish off the expanding brackets in this first fraction that we have here. So we're going to take the 2 and multiply by 2, which gives me 4. Then we're going to multiply by the negative x, which gives me negative 2x. And then we're going to move on to the second term in the first bracket. So negative x times 2 is negative 2x. And then we're going to multiply the negative x with the negative x to get positive x squared. And that's all over 9, like that. And don't forget to write in the plus 10, subtract 5x, like that. Now let's think about how we can simplify this here further. Well, the bracket here is being multiplied by 18. And remember, that 18 is essentially 18 over 1. So we can do some cross-cancelling here, okay, because there is a common factor of 9 between the 18 and the 9 down here. So we'd divide this 18 by 9 to be left with 2, and divide the 9 down here by 9 to be left with 1. Okay, so outside my bracket, I'm left with 2 over 1, which is 2. Then inside my bracket, well, we got 1 in the denominator, so we don't have to write that in, because when we divide by 1, we just get left with the numerator. So I just have to simplify my numerator, which is going to be 4. And then we've got negative 2x, subtract 2x is negative 4x. And then finally got the positive x squared, which I can write in like that. And then close bracket, and we got our final terms to write in. Plus 10, subtract 5x. So this is already looking better, because we don't have any fractions left over. Okay, this looks like it's going to simplify down to a quadratic. But let's expand this further, because it's all multiplying by 2. So 2 times 4 is 8. 2 times negative 4x is negative 8x. and 2 times x squared is positive 2x squared, plus the 10, subtract 5x, and then collecting like terms, we've got 2x squared, which I'll write first. Then we've got our x terms are negative 8x and negative 5x, which is negative 13x. And then finally, we have 8 plus 10, which is going to leave me with 18. So this is a simplified expression for the composite function g f of x. So we have completed step 2. So now we have to move on to step 3. So what I'm going to do is just circle this composite function I just found, and step 3 up here says we need to add what we found in step 1 and step 2. So the two things I've circled in red, we now need to add them together. Okay, because if we look at the initial question, we need to do the inverse of f of x plus gf of x. So let's write step 3 down here. Okay, the inverse of x plus gf of x is going to be equal to this expression here. So we'll write it below, negative 3x plus 2, and then plus my other expression circled in red, this one here. So that would be plus 2x squared, take 13x, plus 18, like that. Okay, and because it's addition, we don't need to write brackets around it like that. Now let's simplify and see what we get. So I'll write the 2x squared we've got first, and then let's do our x terms. So negative 3x, take 13x is negative 16x. And then finally, positive 2 plus 18 gives me 20. And that should be my final answer, because it's in the form ax squared plus bx plus c, which is what the initial question asked me. So I can clearly write out what my values of a, b, and c are. Okay, a is going to be equal to 2, this value here multiplying x squared. B is going to be negative 16, we need to include the sign, and c is going to be 20. So that would be my final answer to the question. So we're going to look at one final question linking together inverse functions and composite functions. So we've got f of x here and g of x, and we're being asked to find these two functions here. Okay, let's just compare the two. The first one says f of the inverse of g of x. Okay, so this is a composite function, and if we put our bracket notation in, brackets would go here and here like that. And essentially what this is saying is we need to find the inverse of g of x and substitute it into f of x, like that. Now the second one is a little bit different. Okay, the reason this one is different is because we got the brackets in there to begin with. Okay, the brackets around the f and the g. So we need to do what's in the brackets first. We need to find the composite function g of x, and then we need to find the inverse of that function. Okay, so they are slightly different, don't mix up the two. So let's just go through the working. So let's start with part A. I'm just going to put my brackets back in around like that. So we need to find g of x and then sub it into f of x. So for part A, I'm going to write g of x is equal to 5 subtract 3x, and then replace the g of x with a y. So y is equal to 5 subtract 3x. Then we're going to replace the y's with x's. So I'd replace this y to get an x, and then replace this x to get a y, like that. Now let's rearrange to make y the subject. So I'm going to subtract 5 from both sides. So we would get x subtract 5 is equal to negative 3y. And then we're going to divide by negative 3. So we get y is equal to x take 5 over negative 3. And because the denominator is negative, I can put that negative sign to the front of my fraction. So we'd have x subtract 5 over 3, because a positive divided by negative gives us a negative. And then replace the y with our inverse function notation. So inverse of g of x, like that. Now I try and find the function they're asking for. So we need to find f of the inverse of g of x. So I need to substitute the inverse I've just found into f of x. So I'm going to replace this inverse g of x with what it's equal to. So I would have f of, open brackets, negative x subtract 5 over 3. And then let's go to f of x, which is all the way back up here. And we're going to replace the x's with the fraction I've got in my brackets. So if we look on the right-hand side, we have 1x, which I'm going to put brackets around like that. And in those brackets, I'm going to insert that fraction. So we'd have 2 lots of, and then our fraction, negative x subtract 5 over 3. Close bracket, and then we got the subtract 3. Then in terms of simplifying further, what we could do is recognize that this 2 is essentially 2 over 1, and it's multiplying our other fraction, so that 2 is going to multiply to the numerator. Okay, so on the numerator, I would get 2x subtract 10 when I multiply both terms by 2. We've got our negative sign in front of our fraction, and then 3 in the denominator, which doesn't change because I multiply by 1. And then we've got the subtract 3, but that is my final answer. That is f of the inverse of g of x. Okay, so that is part A complete. Now let's have a look at part B and try and get the answer for that, and then we can look at the 2 full processes. So for part B, we need to start by doing what's in the bracket, so that's finding fg of x. So I need to find that composite function first. So fg of x, written in my preferred notation, would be the following, with brackets around the g of x, like that. Okay, so what I'm then going to do is replace my g of x in here with 5 subtract 3x, because I'm going to have to substitute 5 subtract 3x into f of x. So I'd have f of 5 subtract 3x. So in f of x, wherever there's an x, I'm going to replace it with 5 subtract 3x. So I'm going to put brackets around this x here, which I'm now going to replace. So I'd have 2, open brackets, 5 subtract 3x, close bracket, and then I've got the subtract 3. And if we simplify by expanding the brackets, we get 10, subtract 6x, subtract 3. And collecting my like terms, 10 subtract 3 is 7, subtract the 6x. So I have found fg of x, which is this function down here. So I'll just write equals to fg of x at the bottom, just so it's clear. I now need to find the inverse of this function. So to do this process, I'm going to start by replacing the fg of x with a y. So I would get y is equal to this here, so 7 subtract 6x. And then I'm going to replace my y's with x's. So replace that y with an x, and replace this x with a y. So I will get 7 subtract 6y. And then I'm going to rearrange to make y the subject. So I'm going to subtract 7. So we'd have negative 6y is equal to x subtract 7. And then we're going to divide by negative 6. To get my final expression, which is y equals x subtract 7 over negative 6. However, because our denominator is negative, I can put that negative symbol to the front of my fraction, and we'd have x subtract 7 over 6. And I'm going to replace my y with my inverse function notation. Well, we're finding the inverse of fg of x, so I would write fg in brackets inverse of x like that. And that would be my final answer. Okay, so just be careful with the differences between those 2 questions, as it does catch students out. So we're now going to look at how we can use the graph of a function. So it says the graph of y equals f of x is shown. So that's this graph over here. So it looks a bit like quadratic. And if we look at the labeling, we have our y-axis labeled as f of x, okay, because f of x essentially takes the place of y. And then we got a horizontal axis, which we'll label x. Now we need to use the graph to do the following. So the first one says find f of 1. So what does this mean? Well, this means usually that we're going to substitute 1 in for x in f of x. Okay, but I don't have the expression for f of x, so I'm not going to do that, so I'm going to use the graph. So the idea is this one here, that is your x value. That's your input. So when you're being asked to find f of 1, you're being asked to find your output, which is essentially your y coordinate. So what I need to do is go to my graph and identify where is the x coordinate equal to 1. So what I'm going to do is go to my x-axis, okay, which is our horizontal axis, and think about where is the x coordinate 1, well, it's here. And now we need to get to our curve. So what I need to do is draw a vertical line, so either up or down to get to my curve. Now going downwards is not going to be much help. I'm not going to get to my curve. So we're going to have to go upwards. So my vertical line would look like this until you hit your curve, which is this point here. So this point here has an x coordinate of 1. So what you now want to do is go horizontally until you hit your axis, okay, which is like this. And that is my output. Okay, we have found that f of 1 is equal to 8. So I'm going to write in my answer over here. F of 1 is equal to 8. Okay, essentially that's my output when I substitute 1 into my function. So let's look at our second one. It says find f of negative 4. So this time negative 4 is my input. That is my x value. So I need to find my output. So I'm going to go to my x-axis and identify -4, which is going to be this point here. And once again, I'm going to draw a vertical line until I hit my curve. Okay, so going down, again, won't be particularly helpful. I'm going to have to go upwards until I hit my curve, which is this point here. So I need to know the y-coordinate of this point, and that's going to be my final answer to f of -4. So if I go across, I get to 3 on my y-axis. So the final answer is that it is equal to 3. Let's have a look at part C. So part C is a bit different, as the command word is solve. So I'm trying to find an x value that makes this equation true. So this time my end result is going to be on my x-axis. Now the idea is the output of this x coordinate here is equal to 0. So 0 is your f of x value, or another way of thinking about it, it is your y value. Okay, so essentially I need to go to my y-axis, which is of course my vertical axis, and I need to think, where is y equal to 0? Well, y is equal to 0 at this point here. So on my y-axis, that is where y is 0. So what I now need to do to adapt my process is I need to go horizontally to see where on my curve is the y-coordinate equal to 0. So I am going to draw a horizontal line at that height. So my line, if I just rub off what I've done so far so that doesn't get in the way, is going to essentially just be my x-axis. Okay, so my line is going to be like this. Those are all the points where the y-coordinate is 0. We need specifically the points on my curve. So where does my red line intersect with my blue curve? Well, that is this point here and this point here. And if we have a look at our x-coordinates, we have x equals -3 and x equals -1. So they are both solutions to the equation. Okay, it would be that x is equal to -3, and I'm going to write comma -1 like that. Okay, so we'd have two solutions. Let's look at our next equation. So our next one is f of x is equal to 3. So just like the previous question, we are solving, and therefore our 3 is our output. Okay, our 3 is our f of x value, or you could call it your y value. We're trying to find the x value that yields this y value. Okay, so I need to go to my y-axis, my vertical axis, and identify where is 3 on it. So that is going to be here. And then I'm going to draw a horizontal line at this height to figure out which points on the curve have a y-coordinate of 3. So that would be across like this. So then let's consider, where does my orange line intersect my blue curve? Well, it's going to be this point over here, but then also this point here. Okay, so what I want to do next is identify the x coordinates of these 2 points. So I'm going to draw vertical lines going down to my x-axis. So down like this, which gets me to -4, and then down like this, which gets me to 0. So those are going to be my 2 solutions. I can write out that x is equal to, and we've got -4, 0 like that. So once again, we've got 2 solutions. Now let's look at part E. So it says f of x is equal to k. So our function is equal to some output k. So k is essentially a y coordinate. And this equation has no solutions. There are no x values that make this true. We need to state the possible values of k. So that implies there's going to be multiple values. Well, if we look at my working for the previous equations, I ended up drawing a horizontal line at the height of this numerical value here. So for part D, that was 3. For part E, that is k. So I'm going to have to draw a horizontal line at k on my y-axis, and I want no solutions. Now, the number of solutions is the number of points of intersection, so I want my horizontal line to not intersect with my curve at all. So therefore, if I drew that line up here, well, we're going to have 2 points of intersection, one here and one there. So that's not going to be helpful. What I need to do is move this horizontal line down here, okay? Because then we have 0 points of intersection. So for that horizontal line, we got no solutions. We got no solutions for that horizontal line. So where does it start where my horizontal line will start having no solutions? Well, it starts here, okay? So at this line here, which is at -1 on my y-axis, we have one solution because we intersect here. Anywhere below this, we're going to have no solutions because we're going to have 0 points of intersection. So for part E, our value for k needs to be smaller than this one here. So k needs to be smaller than -1. Okay, so any value of k smaller than -1 gets us no solutions. Now let's have a look at part F. So it says write down the coordinates of the turning point of y equals f of x. Well, our blue curve looks a bit like a quadratic. Okay, and the turning point of a quadratic is either the highest point or the lowest point. In this instance, it is going to be our lowest point, okay, because we got a minimum point. Sometimes it's called a vertex instead of a turning point. I need to write out the coordinates of this purple point I've already marked. So the coordinates are -2 for my x value, and then my y value is the -1 here. So it would be -2, -1. And how does this link to part E? Well, it's at the turning point. Once we go below that, we're going to have no solutions in part E. So those two bits link together. We're now going to start investigating transformations of functions. So if we look here on left at the three equations we've got, we have y equals x squared, which I'm going to call equals to f of x. So we're saying f of x is equal to x squared. But our next one is y equals x squared plus 3. Well, how is that related to the top one? Well, they both have the x squared in it. The only difference is the second one has this additional plus 3. So relating it to the top one, I could write this is equal to f of x, which was defined as the x squared, which we have here, and then plus an additional 3 like that. Now, if we look at the bottom one, we've got the x squared again. Okay, so that's my f of x. However, we're now subtracting 2. So I'm going to write a subtract 2 here. Now let's investigate the graphs of these three functions. So let's start with the red one and the blue one. So the red one is y equals x squared, which is sort of the basic type of quadratic that you can get. And what I'm going to do on the red graph is I'm just going to mark on the turning point to help us investigate what's going on here. So that's at 0 on the y-axis. Now let's look at the turning point of the blue curve. So y equals x squared plus 3. Well, that's this point here. And on the y-axis, that is at 3. So the turning point from the red curve to the blue curve has moved upwards 3 units. In terms of how I could write that out as a sentence, I could say it's a translation by, and I would use a vector to describe our translation, and the horizontal component of our vector would be 0 because it hasn't moved to the left or to the right. The vertical component would be positive 3 because we've gone 3 upwards, like that. Now let's see whether this checks out for other points other than our turning point. Okay, so I'm going to pick a different point on my red curve. So let's go with this point here. Now let's carry out this translation here. So this means go 3 upwards. So what I'm going to do is go 3 units upwards. So on my y-axis, okay, 1 unit would be 2 boxes, just to be clear. Okay, so that would be 1 unit. This would be another unit. This would be another unit. And we end up on the blue curve there. So it seems that this translation does check out for this other point I've picked. If we move this point upwards 3, we're going to be on our blue curve. Let's pick another point on my red curve. So let's go for this point over here. And let's do the same. Okay, we're going to go 1 upwards, 2 upwards, and then 3 upwards. And once again, we get to my curve. So it does seem that every point on my red curve has been translated by 0, 3. Therefore, we would say that the transformation from the red curve to the blue curve is a translation by 0, 3. And if we look at the equations of those two curves, well, you can see a plus 3 here for my second blue curve there. Okay, and that is where the 3 comes from in the vector. Now let's have a look at our green curve instead, and we're going to compare our green one to our initial red one. So this time, we've got our turning point on our red curve again at 0, 0. However, our turning point on the green curve is down here at -2 on my y-axis. So once again, we should only have to move vertically, but this time we'd have to move 2 units downwards. So to reflect that, I'm going to say -2. So if I was writing out a transformation for this, I would call it a translation again. However, my translation would be by 0, -2, like that. Now let's just check, does this work out for other points on my red curve? So I'm going to pick a different point. So let's go with this point here. And I'm going to try and move this point down 2 units. Okay, so if we're moving down 1, we're here. Then we move down 1 again, we're down here. And we are on my green curve. Okay, so if we move the orange point 2 downwards, we do get to my green curve. Let's see if this checks out for another point. So I'm going to choose this point up here instead. And let's try and move this 2 downwards. So 1 downwards and then a second downwards. And we are at this point, which is on my green curve. So it seems that every point on the red curve has indeed been translated by 0, -2 to get to my green curve. So this transformation is correct for the entire graph. And if we have a think about where this -2 is come from in the vector, well, if we look at the green equation, it's f of x subtract 2. So it does seem that we can write out a generalization for what is going on here. Okay, if we have y equals f of x, and this graph equation changes to y equals f of x again, but some number is added or subtracted on, so I'm going to write plus a. Okay, so for my blue curve, it was this value here. For my green curve, it was this value here. Well, this represents a transformation, which is a translation by, and would describe our translation with a vector. And if we look at the two vectors I've written out, our horizontal component was 0 in both cases, and then our vertical component was a non-zero number, which I'm going to call a, because it was this value here being added onto the function each time, which ended up being my vertical component. Okay, for the blue curve, it was the +3, which goes down here, and for the green curve, it was the -2, which goes down there. Okay, so this is a vertical translation. Now let's look at a different type of translation. So let's have a look at our next transformation. So we've got our 3 equations here, and I'm going to start by calling the y equals x squared. We're going to call it f of x again. And then let's compare the other 2 equations I've got there to that top one. So the difference between the first one, the y equals x squared, and the next one is y equals x plus 3 squared, is that the x, just the x, has been replaced with an x plus 3. The power of 2 is still there in each instance, but the x has been replaced with an x plus 3. So how can I write that out using my function notation? Well, I would call this equals to, I'd write f again, because there's that similarity with the fact that the x has just been replaced with an x plus 3 and the square's still there. But since the x has been replaced with an x plus 3, inside my brackets, I'm not going to write x this time, I'm going to write x plus 3 instead, which is different to the last transformations we were looking at, where this plus 3 was on the outside. Okay, it was being added on to the x squared, as opposed to being added on directly to the x. Now, if we look at our bottom one, the x in the bottom one has been replaced with an x subtract 2, so I would write f of x subtract 2 instead, like that. So now we've got all my equations in terms of f. Now let's go and investigate what transformation is occurring. So I'm going to start by marking on the turning point of my red curve, my top one, y equals x squared, which is at 0 on the y-axis. Now this time we're not moving up and down. Okay, it's not a vertical transformation. It is a horizontal one instead. We're moving to the right or to the left. So let's compare the red curve to the blue curve. So I'm going to mark the turning point on the blue curve, which is here, okay, which is at -3, like that. So turning point has moved 3 to the left, which you could use -3 to represent. So the transformation is a translation, and we could say that is a translation by, and our vector this time would be a bit different, because our horizontal component would be the -3, and then we haven't moved up or down, so our vertical component would be 0. Now let's just check, does this check out for other points on my red curve? Well, if we take, for example, this point here, then let's move it 3 to the left. So on my x-axis, 1 unit to the left is 2 boxes. Okay, so this would be 1 unit, this would be a second unit, and this would be a third unit. So we end up on my blue curve. Okay, we moved 3 to the left to get from my initial point to my end point, and we've ended up on that blue curve. So it seems that this translation does check out for other points on the curve. Let's just check one more just to be sure. Okay, I'm going to pick this one up here, and let's move 3 to the left. So 1 to the left, 2 to the left, and then 3 to the left, like that. And we're on my blue curve. Therefore, all the points on the red curve have been translated by -3, 0. So now let's compare my red curve to my green curve instead. Okay, so let's start by marking on the turning point of my green curve. So the turning point of my green one is over here. Okay, it's at 2 on the x-axis, whereas my initial turning point was at 0 on the x-axis. So it seems that we have moved 2 to the right instead. Okay, so my transformation would be a translation again. And this time my vector would be 2 0 like that, because we move 2 to the right, however we move 0 up or down. Now once again, let's just check, does this check out for other points on my red curve? So let's pick this point here. If I move this 2 to the right, well then I'd be going 1 unit to the right, then another unit to the right, and I do end up on my green curve. Let's pick another point, so we'll go with this point over here, up here on the left. And if we moved 2 to the right, we'll be going 1 to the right, then a second to the right, and we end up on my green curve. So it seems that this translation here checks out for all points on my red curve in terms of moving to my green curve. So that should be the correct transformation between the graphs. So once again, we can write out a generalization. Okay, if we're starting with y equals f of x, which was my red curve, okay, then let's say the new equation is y equals f of, and then in my brackets, I'm going to write x plus a, because if you look at both my blue curve and green curve equation, we have x plus a number or x subtract a number, so we're representing that with a. Then we would call this a translation by, and then I'd write my vector. Now, if we look at the two vectors we've got, the vertical component is 0 because we're only moving horizontally, we're not moving up or down. And then my horizontal component is related to the number inside the brackets. Okay, in my first instance, we got a -3, whereas we got a +3 inside my brackets. In my second instance that we looked at with the green curve, we got a +2 as my horizontal component, whereas in the brackets, we got a -2. Okay, so it seems we changed the sign. We multiply by -1. So we're not going to write a, we're going to write -a instead. And that would be our generalization for a horizontal translation. Now let's look at a different type of transformation. So we got our next transformation here. Now let's look at our two equations and just compare them. So y equals x squared, I'm going to call that f of x again. So what has changed between the red equation and the blue one? Well, the only thing extra in there is this negative sign, which represents multiplication by -1. Essentially, we have gone to the initial x squared and we multiplied by -1. So in terms of representing that in terms of our function notation, we essentially taken f of x, which was x squared, and we multiplied by -1. So we're going to have negative f of x. Now let's look at the graphs and try and see what's happened here. Well, it looks like the red graph has been flipped to get to the blue graph. But what transformation represents flipping? Well, that would be a reflection. And when we describe our reflection, we have to state our line of reflection, which I think is quite clearly the x-axis. So it's a reflection in the x-axis. Now, if we look at the turning points, which is what we were investigating previously, the red turning point is here at the origin, and the blue turning point is also there, which makes sense if it's a reflection in the x-axis, because any point on the x-axis should remain exactly where it is when it gets reflected. We'd call it an invariant point when it doesn't move during a transformation. Now, let's pick a different point instead, just to investigate things further. If we go with this point here, okay, this point has the coordinates 2 to the right and 4 up, so 2, 4. Well, when you're doing a reflection in the x-axis, you're moving the curve vertically. So it should only be the y-coordinate which changes when you reflect. And if we go through the process of reflection, we figure out how do we get to our line of reflection, which is going downwards like that. So we've gone down 4 on our y-axis. Okay, so on the other side of my line of reflection, I'm going to go down 4, okay, which gets me to this point here. And if I write out its coordinates, this is the point 2, -4. And if we're moving vertically, our x-coordinate is not changing because that measures how much we are to the right or to the left. Whereas our y-coordinate does change, and the change that happens is you multiply it by -1. Which makes sense if you look at the equations, because if we're starting with y being equal to x squared, and if we're multiplying x squared by -1, then essentially the y-coordinate is being multiplied by -1. So let's write out my generalization. Okay, if we have y equals f of x, and it goes to y equals negative f of x, so we take f of x to multiply by -1, then we have ourselves a reflection in the x-axis. Now, another way of saying this is by giving the equation of the x-axis. Well, on the x-axis, if you take any point on there, for example, this point here has the coordinates -4, 0. Then this point over here has the coordinates -6, 0. Well, the y coordinate is always 0, so we could say the equation of the x-axis is y equals 0 instead if you wanted to. So let's have a look at our final transformation. So this time we're going to look at some linear graphs. So we got y equals 3x plus 2, which I'm going to call f of x. Okay, so f of x is equal to 3x plus 2. Now let's compare our red graph equation to our blue one. So what's changed? Well, the plus 2 has stayed the same. Okay, the 3 has stayed the same. The only difference is the x in the initial graph has been replaced with a negative x. Okay, so this would be equal to our function f. However, the x has been replaced with a negative x, so I'm going to put a negative x in the brackets in place of the x. Now, in terms of writing out this equation in the most simple way, usually you would write negative 3x plus 2, because the 3 is being multiplied by the negative x. I just wanted to make it a little bit clearer as to what the relationship between the two functions are. Okay, so this time, instead of that negative sign being outside the function multiplying the whole function, we're now multiplying the x only. So let's have a look at the graphs and see what's happened. So you can see the graphs of the red one and the blue one here, and hopefully you'll be able to see that what's happened is the red one has been flipped over, but this time it's been over the y-axis, so this represents a reflection in the y-axis. Now let's investigate some points and how they have changed. So I'm going to start by choosing a point. We'll go with this one here. Okay, so that is 1 to the right on the x-axis and then 5 up. So that's the point 1, 5. And then if I was to reflect this, I'd figure out how can I get to my line of reflection. So my y-axis, so like this, so 2 to the left. And then I'm going to do 2 to the left on the other side. So I'd go 2 left like this, and then I hit my curve there. That's where my point ends up. And what's the coordinates of this point here? Well, we're now going -1, okay, because we're going 1 to the left on the x-axis, and then we're still going up 5, okay, so the y-coordinate would still be 5. So the y-coordinates have stayed the same, okay, so when you reflect in the y-axis, the y-coordinates won't change because this is a horizontal transformation. You're only moving horizontally, you're not moving up or down, so y stays the same, and it's your x-coordinates that will end up changing. And if we look at what's happened, we've gone from 1 to -1, so we multiplied by -1. Okay, when you reflect in the y-axis, you're going to multiply your x-coordinate by -1, which if we link back to our functions, you're essentially taking x and replacing it with -x. In other words, you're multiplying the x by -1. Now, there's one other point I just want to talk about before we get into a generalization, okay, and that is, in this case, the y-intercept. Okay, so that's this point here for the red graph, which is also the y-intercept of the blue graph, which makes sense because this point here is on my y-axis, it's on my line of reflection, so it shouldn't move during the reflection, okay? We'd call it an invariant point. So let's write out our generalization. If our initial equation is y equals some function of x, and then our equation after the transformation is y equals the function of -x, then this represents a reflection in the y-axis. And let's just think of another way of describing the y-axis. Well, if I pick a point on the y-axis, for example, this point down here, well, this has the coordinates 0, -4. If I pick another point, okay, for example, this point here, okay, this has the coordinate 0, -2. Okay, so the x-coordinate is always 0. So you could call the y-axis x equals 0 instead if you wanted to. But you only have to say either the y-axis or x equals 0. So we're now going to look at finding the equation of a function after a given transformation. So I've got a table here summarizing the 4 transformations we've looked at so far. So if we start with y equals f of x, you can see the equation for each transformation written here. Okay, so it's good to have this in front of you initially whilst you don't have the transformations memorized in your head. So let's look at the question that we're trying. So let y equals g of x. So I haven't been given what g of x actually is, but it doesn't matter. It's just some expression involving x. It might be x squared plus 3x. It might be x plus 5, but it doesn't matter to the question. We can still answer it. Our answer will just have to be given in terms of g of x. So we need to find the new equation for y after the following transformations. So let's start with part A, which is a reflection in the x-axis. So let's look at our table of transformations. And which one's for a reflection in the x-axis? Well, it's the bottom one, so we're considering this equation here. So essentially, to get from your initial function f of x to the one with a reflection in the x-axis, you have to multiply the function by -1. So what I need to do is go to my g of x, and I need to multiply -1. So I would get y equals negative g of x like that. And that would be my final answer. Let's have a look at part B. Now part B is slightly different. We're considering a reflection in the y-axis instead. So where is a reflection in the y-axis in my table? Well, it's going to be this one here. Okay, so let's start writing out my equation. It's going to be y equals 2. And let's think about what this bit of information is telling me. This is telling me if I take f of x and I want a reflection in the y-axis, then I need to replace the x with a negative x. So what I would do is go to my g of x, and I would replace the x in here with a negative x and get g of negative x like that. And that would be my final answer. So let's have a go at part C. So part C, we're now moving on to translations. Okay, and we got a translation by 0, 7. So if we look at my table, my translations are my top two, so we're considering those. And the horizontal component of this vector is 0. So which of my two translations has that scenario? Well, it's going to be the top one. Okay, so it's going to be this one here, y equals f of x plus a. So what this is saying is if you start out with f of x, okay, to get a translation of 0a, we would take that value of a, our vertical component, and we would add it on to our initial function. Okay, so for part C, it's going to be y equals g of x plus or potentially minus some value. In this case, our vertical component is 7, so we are just going to add 7 on like that. And that would be my answer. Let's have a go at part D. So part D is another translation. However, this time the vertical component is 0. So the translation I'm going to consider is going to be this one here, the second one in the table. And what this is saying is if you're starting with f of x, okay, you're going to replace the x with an x subtract a, okay, where the a is the horizontal component of my vector. So we can write out my answer. It's going to be y equals g, and then open brackets x, and then we need negative a. In our case, a is negative 6. So if I want negative a, I have to multiply that by -1. So I'm going to get positive 6 inside my bracket, and then close bracket like that. Okay, so for our horizontal translations, we should be changing what is inside the brackets. Let's have a look at our last one. So this one is a bit more complicated, because as you'll see in our translation vector, neither of our two components are 0. So it doesn't perfectly match with either of the top two rows in my table. However, we can combine the top two rows in my table together to get a translation where both the horizontal and vertical component are non-zero numbers. And actually part E is essentially just a combination of part C and part D. Okay, in part C, we had 7 as our vertical component, which matches down here. And in part D, we had -6 as my horizontal component, which matches down here. We're going to do a horizontal translation and a vertical translation. And to carry this out, we are going to combine our answers from part C and part D. So I would get y equals, and it would be the g of x plus 6. And then we'd have the plus 7 written on the outside for our vertical component. And that would be my final answer. So we're now going to look at a harder question. So I've got my summary on my transformations here again. But let's have a look at our actual question down here. So it says h of x, and this time we're given the actual equation for the function. Okay, it's 2x squared take 5x plus 7. And then we're asked what would be the equation after the given transformations. Okay, so let's work our way through. Let's start with part A, which is a reflection in the x-axis. So if I go to my table, that is this one here. So remember, when we're reflecting in the x-axis, we are taking our initial function and we are multiplying by -1. So let's start by writing out what our equation is going to be in terms of h of x. Okay, so we're going to multiply that function by -1. So I would get negative h of x. Now, in order to get the final answer, what I need to do is go to the right-hand side, and I need to multiply this by -1 as well, because I need to do the same thing to the left-hand side and the right-hand side. So I would write -1 outside the bracket, and then inside the bracket, I would write out the entire function for h of x. So 2x squared, take 5x, plus 7, like that. And that could be your final answer. But let's expand the brackets, and I would get negative 2x squared, plus 5x, and then subtract 7. And the idea is, if I was to sketch h of x, and I was to sketch this one here, the relationship between the two would be that they are a reflection in the x-axis of each other. Let's have a go at part B. So part B is a reflection in the y-axis instead. So in my table, that is going to be this one here. And this is saying that if you've initially got f of x, you need to replace the x there with a negative x to get your new equation. Okay, so for h of x, I'm going to replace the x with a negative x. So I get h of negative x is equal to, and then on the right-hand side, I have to do the same thing. I have to replace all the x's with a negative x in order to find h of negative x. So I'm going to put brackets around all my x's, so there, and then here as well. Okay, and let's start writing out. We'd have 2, open bracket, and it's going to be a negative x, close bracket, squared. Then we've got negative 5, open bracket, negative x, close bracket, and then plus 7, like that. Now let's go through and simplify to get our final answer. Well, if you do negative x squared, that's negative x times negative x, which is positive x squared. So I'd get 2x squared. And then we got negative 5 times negative x, well, that's going to be positive 5x. And then finally, we got positive 7. Okay, so if I was to sketch this graph and then the original function I was given, they would be a reflection in the y-axis of each other. Let's have a look at part C. So in part C, we're moving on to our translations. And our first translation here has a horizontal component of 0. So if I go to my table, we're looking at the top one, the y equals f of x plus a. So in order to get from my initial function to this one here, we just have to add on a, which is our vertical component of our translation. So let's write it out in terms of our h of x. Okay, it's going to be h of x. And then what is our vertical component of our translation? It's negative 5. So I'm going to add that on. So we'd have h of x subtract 5. So I now need to go to the right-hand side and I need to subtract 5 from it to get my final answer. So the 2x squared and the negative 5x stays the same. Plus 7, well, if we subtract 5, we get plus 2. Okay, so if I was to sketch my initial function, h of x, and then the one that I just found, they would be a translation of 0, negative 5 of each other. So going from the h of x to my new function would be a movement of 5 downwards. Let's have a go at part D. So part D is a translation again. This time, though, it's our vertical component, which is 0. So we're now going to be looking at the second row in my table, okay, which says if I want my equation, I need to go to my initial function and replace the x with an x subtract a. So if I write it out in terms of the h of x, it's going to be h, open brackets, x. And then we just need to figure out what are we going to write in terms of the negative a. Well, our horizontal component is meant to be our a. So that is going to be 4. And then we want negative a, so we need to multiply by negative 1 to get negative 4. So it's going to be x subtract 4 inside my bracket like that. So I now need to find h of x subtract 4. So to find that, I need to go to h of x and replace the x with an x subtract 4. So I'm going to put brackets around all my x's like this. And I'm going to write that statement out, but inside the brackets, I'm going to write x subtract 4. So we've got 2, open bracket, x subtract 4 squared. Take away 5. X subtract 4, and then plus 7. And then we should go through and simplify. So we have x subtract 4 to the power of 2. That's going to be x subtract 4 multiplied by x subtract 4. If I expand this single bracket here, I would get negative 5x plus 20, and then we've also got the plus 7. Then we can do this double bracket expansion. So I would have x times x, which is x squared. Then the first x times the negative 4 is negative 4x. And then we would have negative 4 times x is negative 4x. And then negative 4 times negative 4 is positive 16. And then I'd write everything outside my brackets as well. So the negative 5x. And then simplifying, we've got 20 plus 7 is plus 27. And then expanding this bracket here, okay, we would have 2x squared. Now negative 4x subtract 4x is negative 8x. Times 2 is negative 16x. And then the 2 times the 16 would give me 32, like that. And then we have the subtract 5x plus 27. And then collecting like terms to get my final answer, we'd have 2x squared. Negative 16x subtract 5x is negative 21x. And then the 32 plus the 27 would give me 59. Okay, and that would be my final answer for the curve after a translation by 4, 0. Let's have a look at part E. So part E is now combining multiple translations together. Okay, we got a horizontal one and a vertical one. So let's start by writing out my equation in terms of h of x. I'm going to write h, and then for my horizontal translation, okay, that is going to be this one here. I'm going to replace the x in the brackets with an x, and then is negative a. Our a is negative 3, so negative a would be positive 3. And then for my vertical component, well, that would be my top row in my table. Okay, we just add on our vertical component. So our vertical component is 6. So I'm just going to add 6 like that. And now I can try and write out my equation. So what I'm going to do is go to h of x and replace all of the x's with an x plus 3. So I would get, if I put brackets around my x's, say like this and then like this, we'd have 2 open bracket, and it would be x plus 3 to the power of 2. Subtract 5, open bracket, x plus 3. And then plus 7. However, we also need to plus 6 onto h of x. So I'm also going to write a plus 6 like that. Okay, now we could expand and simplify, but I think I'm going to leave things there. I'm just going to simplify the part outside the brackets, which is the plus 7 plus 6, which becomes positive 13. Okay, now usually you'd have to expand and simplify, but I'm going to leave it there and move on to part F. So if we have a look at part F, we've now got a mix of reflections and translations. So we've got a reflection in the x-axis and then a translation by 5, 0. So let's start with our reflection in the x-axis. Well, that is the bottom line in my table. What I would go and do is I'd multiply my function h of x by negative 1. So I'd have negative h, and then open brackets, and then our translation of 5, 0, well, that's going to be the second row in my table, okay? And that's going to be where we replace the x with an x subtract a. So we're going to write x, and our value for a is the 5. So if we want subtract a, it's going to be subtract 5, okay? And I need to find the equation of negative h of x subtract 5. So I'm going to go to h of x, okay, and I'm going to multiply it by negative 1. So I'm going to write negative 1, open brackets. However, when I write out the function, I'm also going to have to replace the x with an x subtract 5. So I'm going to put brackets around my x's like this. And then I'm going to write 2, open brackets, and it's going to be x subtract 5 squared. And then subtract 5, multiply by x subtract 5. And then we got a plus 7, which doesn't have x in it, so stays the same. And then I'm going to close my outer bracket, and actually I'm going to change them to square brackets just so it's a bit clearer. Okay, and the idea is if I was to sketch this graph out, okay, it would be a reflection in the x-axis and a translation by 5, 0 of h of x. Now I could go through and expand and simplify, but I'm going to leave it there. We're now going to look at writing the equation of a curve when given the transformation of a specific point. So we've got our summary of our transformations up here, and let's read the question. So we're told that the point A has the coordinates 2, negative 3, and it's on the graph y equals f of x. Now they're telling us the graph is transformed, and then the point A ends up in the following positions, which are written over here. And we need to find the equation of the transform curve in each instance. So let's start with part A. So in part A, we know that the initial coordinates of A are 2, negative 3. And then in terms of our final position for A, the final position is the negative 1, negative 3. So what we need to do is investigate what has happened to this point. What transformation has occurred? Well, we're told it's a translation. Okay, so that means we're moving to the left or to the right and then potentially up or down. Well, let's look at coordinates. First thing I always look for, has one of the coordinates stayed the same? Well, the negative 3's have stayed the same. Okay, therefore, the y coordinate is unchanged. Okay, so I'm going to write 0 here just to indicate the change is 0. Therefore, in my vector, our vertical component is going to be 0. Then for our x coordinates, to get from 2 to negative 1, well, you'd have to subtract 3. So therefore, the horizontal component of my vector would be negative 3. So we have ourselves a translation by negative 3, 0. So now we need to write out the equation of this curve. So we know we're starting with y equals f of x. Okay, if we're doing a horizontal translation, okay, that is going to be our second line in our table there. So we're going to be looking at this equation specifically. And we need to ask ourselves, what is our value for a? Well, a is our horizontal component, which is negative 3. So in my bracket here, because it's negative a, we are going to put positive 3 instead. So when I write out this equation, it's going to be y equals f of x plus 3, like that. And that would be my final answer. Let's have a look at part B then. So in part B, the point A has moved to the point 2, 0. So I'm going to write 2, 0 here. And we're once again told it is a translation specifically. So let's compare our coordinates. We'll note that the x coordinates have stayed the same, so the movement there is 0. Whereas for my y coordinates, we've gone from -3 to 0, so we're adding 3. Okay, so if I was to write out my vector or my translation, my horizontal component this time would be 0 because the x coordinate has not changed. Whereas our vertical component would be the +3, okay, because the y coordinate has increased by 3. Now, if we're looking at a translation that is vertical, okay, we are looking at the top row in my table here, and my value of a is going to be 3. So now we can write out our equation. It would be y equals f of x, and then we're going to add on our value for a, which is 3. So I'm going to write +3 like that, and that would be my final answer. So let's look at part C. So our point A has gone to the point 2, 3. So I'll write that below here. And this time we're looking at a reflection. We should be concentrating in the bottom 2 rows in my table. Let's have a look at our coordinates. And the first thing I notice is that our x coordinates have stayed the same. It's only the y coordinates that are changing. So if we consider this on an axis, given that it's a reflection that we're looking at, the point 2, -3, so 2 to the right and then 3 down, would be down here. So that's 2, -3. If you were to plot the other point, which is the 2, 3, well, that's to the right, but it's 3 up. So that's going to be up here like that. Well, clearly there's a reflection in the x-axis. Okay, that would be our transformation. So we're considering the bottom row in our table. So our equation is going to be y equals -f of x like that. So that's my final answer. So let's look at part D. So we've got our final position of the point A. It's -2, -3. And this time we're considering a reflection again. So let's look at our coordinates. Has either of them stayed the same? Well, I note that the y coordinate has remained the same. So you might already be thinking, which type of reflection is this? But let's just plot it on the axis just to confirm. So I've got my original point A plotted down here. Now let's plot my final point, which is the -2, -3. So -2 is 2 to the left, so over here. And then -3 is 3 down, so we're down here. And clearly this is a reflection in the y-axis. So in our table, we should be looking at this line specifically. And our equation is y equals f of -x. So that would be my final answer. Let's look at our final scenario E. So we've ended up in the position 5, 9. And we're back to a translation. So let's compare both of our coordinates and see what's happening. So to get from 2 to 5, we'd have to add 3. To get from -3 to 9, we'd have to add 12. So both coordinates have changed. So therefore, our translation vector will have a non-zero horizontal component and a non-zero vertical component. So our horizontal component is how much the x has changed by, so +3, and our vertical component is how much the y has changed by, so that's +12, like that. So that's my translation vector. In order to write out my equation, we're going to have to consider both the top 2 rows, and we'll have to do a combination of both. Okay, so if we're starting with y equals f of x, we need to figure out what our values of a are going to be in each case. So let's start with our vertical part of our translation. So we got 12 down here. So a in this top part is going to be 12. Okay, we're going to add on 12 to the whole function because that represents our vertical translation. And then the a for our horizontal component is 3. So therefore, we're going to write a 3 inside this bracket here. So we're going to end up with -3. Okay, because it's always the opposite sign. If we got +3, it's going to be -3 in the bracket. So what I can write is y equals f of and an x. And then it's going to be subtract 3. And it's going to be +12 outside like that. And that would be my final answer. So we're now going to look at describing transformations when we're given the initial equation and the final equation. Okay, so we've got our summary table here to help us. Let's look at our first question. Describe the transformation from y equals f of x to y equals f of x plus 5. So first off, look at the difference between the two. Well, we've got a +5 in the brackets. Okay, so which of our transformations involves adding a number in the brackets? Well, it's going to be the second one here. Okay, we're looking at a translation. So I need to write that word out first. And then I need to say by whatever vector you think it is. Okay, so in this translation, the vertical component is always 0, so I can write that in. I just need to figure out what a is going to be. Well, if we look at how a relates to the equation, it says negative a in the bracket, so therefore the positive 5 would be the negative a. So the positive a, which is what I want for my horizontal component of my vector, that would be negative 5, okay? We'd do opposite sign. So that would be the final answer to the first one. Let's look at the second one. So this time we are going from y equals f of x to y equals f of x subtract 3. Okay, so once again, let's consider what's changed. Well, we got to subtract 3 outside. So which of the transformations involves subtracting a number on the outside of the f of x? Okay, so she's subtracting 3 from the entire function. Well, it's going to be this top one here. Okay, that negative 3 we got written there represents this a here. So a is negative 3. So that means I can now write out my full statement. It is going to be a translation by, and then we'll write our vector. Okay, and it's going to be 0 for the horizontal component and a negative 3 for the vertical one. But for a vertical translation, it's always the same sign. It's a negative 3 here, given that it's a negative 3 here. Now let's consider some different scenarios. Okay, here's our next question. So we're going from y equals g of x to y equals negative g of x subtract t. So it seems that there are two things going on here in terms of the differences. We have the negative one in front, but we also have the subtract 2 in the bracket. Okay, let's start with the negative 1 in front. Well, that means there's a negative 1 multiplying our function. So which of our transformations involve multiplying our function by negative 1? Well, it's going to be the bottom one here. Okay, our reflection in the x-axis. So we definitely have a reflection in the x-axis. And then we just have to consider the other difference we have here. Okay, which is the subtract 2 in the bracket. Well, if there's being a number subtracting in the bracket, okay, it's going to be this transformation here, our second one in our table, our horizontal translation. Okay, so the negative a inside the bracket is the negative 2. So therefore, positive a would be positive 2. So now we have the information to write out. It's going to be a translation by, and then would state our vector, which is going to be our value of a, which was 2, over 0, like that. Okay, so the transformation in this case would be everything I've written here. The order in which you write it won't matter at GCSE. You won't be given questions where order is significant. At A level, you'll encounter why order matters in some scenarios. Let's look at our second question then. So for our next one, we have y equals g of x subtract 4 subtract 5 to y equals g of x. Okay, so this time we seem to be going towards the more simple equation. Okay, we haven't encountered that scenario yet. So let's consider the other way around. Let's start with y equals g of x and head to y equals g of x subtract 4 and then subtract 5 outside the bracket. And let's just think, what's the transformation in this direction? Because if I want to go in the reverse direction like the question is asking, we just have to do the inverse of that. Okay, so let's go in this direction I've written out here first. So we have a negative 5 outside our brackets. So that's our vertical translation. So we've got a translation. And our vector is going to be 0 for the horizontal direction and then negative 5 for the vertical direction. However, in the brackets, we have a subtract 4. So that represents a horizontal translation. So actually, I'm going to go to my vector. I'm not going to put a 0 up here. We're going to change it. If it's negative 4 inside the brackets, okay, then that means that's our negative a. So our positive a would be positive 4. So I'd put a 4 up here like that. However, remember, we want to go in the inverse direction. So this translation by 4 negative 5 is taking me from the y equals g of x to the y equals g of x subtract 4 subtract 5. Okay, if we want to go in the right direction, which the question is asking for, then we need to do the inverse of this transformation. So the inverse of this vector. So it'd be a translation still. However, the vector would be, instead of doing 4 to the right, we want to do 4 to the left. So that's negative 4. Instead of going 5 down, we want to go 5 up. So that's going to be positive 5. Essentially, you multiply the components of your vector by negative 1. Now let's have a look at a slightly different scenario. So the reason these questions are different is because this time we've been given the actual expressions. It's not written in terms of the function notation. So it might be slightly trickier just to identify what's actually changed. So let's start comparing the equations. Well, in the first one, we have x squared subtract 5x, and that matches with the x squared subtract 5x from here. So the only thing that's changed is our constant terms. We got a plus 9, we got a plus 13. Okay, so what's changed? Well, we have added 4. So if I was to write this in terms of function notation, our original equation could be y equals f of x. And then our equation after the transformation would be y equals f of x, but we've added on 4 to the function. Okay, so I'm going to write a plus 4. And now we can write out our transformation. When we're adding onto the function outside the brackets here, that is going to be our top transformation. It is going to be a translation by, and our vector is going to be 0 for the horizontal component, and then we would write the plus 4 for the vertical component like that. So that would be my final answer. Let's look at our second question. So we've got y equals 5x subtract 2 and y equals negative 5x plus 2. So it seems that the x term has changed because we've gone from positive to negative, but also our constant terms have changed. We've gone from negative to positive. So that would imply we multiplied by negative 1 throughout the entire equation. Because we've got y equals f of x to begin with, and then if you multiply by negative 1, you get y equals negative f of x. So which transformation involves multiplying the entire function by negative 1? Well, it's going to be the bottom one here. Okay, we have ourselves a reflection in the x-axis. So that's our final answer. Let's consider our final question then. So we got y equals 1 over x, and we're ending up with y equals 1 over x subtract 5 subtract 6. So it seems there's multiple changes being made here. Okay, we've got this subtract 5 being introduced in the denominator with the x. So we have a subtract 5 directly on the x. And then we also have this negative 6 outside the fraction. So let's start with the negative 5 in the denominator. So this is specifically on the x. So therefore, in terms of our translations, which are what we should be considering here, given that we're adding and subtracting, okay, we'd be considering this second one here. Okay, essentially, the x we initially had has been replaced with an x subtract 5. Okay, so the x subtract 5 is what we've got in our brackets. Okay, so therefore a is going to be positive 5. So I could say that this is going to be a translation by, and our vector would be, our horizontal component is a, which we've identified as positive 5, and then our vertical component is going to be 0. So that's what's happening in the denominator. But let's also consider the fact that we have the negative 6 there outside the fraction. So essentially, 6 is being subtracted away from the whole function. Okay, when we're subtracting away from the whole function, then we'll be considering our top transformation here. Okay, and our value for a is just what's being added or subtracted. That's going to be the negative 6. Okay, and that is the vertical component of our translation vector. So instead of writing a 0 down here, I'm going to replace it with a negative 6. Essentially, we have a translation in both the horizontal and the vertical direction. So we're now going to look at where a point ends up on a transformed curve. So we've got our summary as usual of our transformations. And then we're told that the point A has the coordinates 4, 3 on the graph of y equals f of x. Okay, that's our starting graph. We need to state the coordinates of point A on the curves with the following equations. Okay, so our first one is y equals f of x plus 2. So you first need to figure out what's the transformation. Well, we got a 2 being added on, so it's going to be a translation. And the 2 is in the brackets. So it's going to be this translation here. So I can write out my vector. My vector of my translation is going to be, well, negative a is equal to the positive 2. So therefore, positive a is equal to negative 2. So we've got negative 2, and then our vertical component is going to be 0. So we've got our translation vector. Let's now carry it out. If we start with the point 4, 3, okay, which is a, well, where does that point end up? Well, the negative 2 means we're subtracting 2 from the x coordinate. So if we got 4 here, if we subtract 2, we end up with 2. And then our vertical component is 0, so the y coordinate is not changing. So if we got 3 here, we're going to end up with a 3 in my answer like that. Okay, so 2, 3 is our final answer. Let's have a look at our second one then. So this one, we have a subtract 5 outside of the brackets of the f of x. Okay, so it seems it's going to be a translation again because we're subtracting. And this time, because the number is written outside, it's going to be this transformation here. So it's going to be a translation, and the vector is 0 for the horizontal component, and then the plus a, which in this case is the -5, that is our vertical component. So we've got my vector, which is saying that the x-coordinate won't change, okay, because it's 0 for the horizontal component, and then for my vertical component, we have a -5, which means the y-coordinate is going to decrease by 5. We're going to have to subtract 5 off it. So if we're starting with the point 43, which we're doing for every question here, we are going to keep the x-coordinate the same as 4, and then we're going to subtract 5 off of 3, which is going to give me -2 as my final y-coordinate. Let's have a look at our next one. So we have y equals f of -x. So the x is being multiplied by -1. Well, which of our transformations does that happen for? That's going to be this one here, our reflection in the y-axis. Okay, so we are reflecting in the y-axis. Now, if we take the point 43, where does it actually end up? Well, if we consider our axes, if we have any point, let's say this one here, and I was to reflect it in the y-axis, it's going to end up over here. Okay, so the point has not moved up or down, it's only moved horizontally. If it's not moving up or down, then the y-coordinate should still be the same. So if it's 3 here, it's going to be 3 there. Whereas the x-coordinate will be multiplied by -1. So we're going to multiply by -1. So we are going to end up with -4. Because we should still be the same distance away from our y-axis. So if this distance here was 4, then the distance over here should also still be 4, but the coordinate would have been multiplied by -1. Let's look at our fourth one. So we have y equals -f of x. So f of x has been multiplied by -1. Which transformation does that occur for? Well, it's our reflection in the x-axis. So this time we have a reflection in the x-axis instead. And once again, let's consider what happens to the coordinates when we reflect in the x-axis. So where does the point 43 go? Well, if we have a point and we reflect it in the x-axis, it's going to end up down here. Okay, so we've only moved up or down. We haven't moved left or right. So our x-coordinate should still be 4. It should be unchanged, the same as it was there initially. And then our y-coordinate would be multiplied by -1. So that 3 gets multiplied by -1 to give me -3 like that. Okay, so the distance above the x-axis here should be the same distance as below the x-axis here. Okay, which would be the case if we just multiply our y-coordinate by -1. Let's consider our final scenario. So this time we have two things going on. We have a -5 inside the brackets and a +10 outside. So we're adding and subtracting. So both of these represent translations. And we just need to write out our vector. So it's going to be a translation by, and the -5 in the brackets links to our horizontal component. Again, we always use the opposite sign. So it's going to be a +5. And then our 10 outside the brackets is our vertical component, and it's equal to it. So it's going to be a +10 like that. That means we're increasing the x-coordinate by 5. We're adding on 5. And we're increasing the y-coordinate by 10. So we're adding on 10. So the point 4, 3 would end up at the point where 4 has 5 added onto it. So we get 9. And then the 3 has a 10 added onto it. So we would get 13. And that would be my final answer. So we're now going to look at drawing a picture of a transformed graph. So we've got a summary of our transformations here. Let's look at the question. We've got the graph of y equals f of x being shown below on the diagram. Now we need to sketch y equals f of x subtract 1. So step 1 is to figure out the transformation between these two functions. So what's changed? Well, we got this subtract 1 inside the bracket. So this should be a translation. Then we just need to consider what is our vector. Well, given that the -1 is inside the brackets, we're looking at this one here. Okay, so the -1 is the -a. So +a is +1. So our vector is going to be 1, and then our vertical component 0 like that. Okay, so we need to go to the graph that's already drawn here, which is y equals f of x. And we need to translate all the points by 1, 0. So what you should do is go to some of the points where you can clearly see the coordinates. So for example, the turning point could be a good one because it goes through the corner of a box, and you need to carry out a translation by 1, 0. So that means move the points 1 to the right. Okay, so if this point moves 1 to the right, it's going to end up here. Okay, so that's that point done. Let's pick another point. that I can read the coordinates of. So this point here goes through the corner of a box. We move it one to the right, it ends up here like that. Okay, let's pick another point. So this point here, okay, if we move it one to the right, it ends up over here. And then if we look at the points on the axis, which I can clearly read here, okay, if we move that one to the right, it's going to end up here. And then we have this point here, which I can clearly read the coordinates of. If we move it one to the right, it should end up there. Okay, so we need to get those points perfectly because we can read the original coordinates perfectly. Now we can draw in our curve. Okay, so it's just going to go through those red points and it's still going to have the same shape, which looks a bit like a quadratic. Okay, so it's going to look a bit like this. And that would be the graph of y equals f of x subtract 1. That would be my final answer. Let's look at another scenario. So we got the same original graph, which is y equals f of x, and this time we're being asked to sketch y equals f of x subtract 2. So once again, let's consider the transformation. So we've got a negative 2 outside our brackets of f of x. Okay, so it's going to be a translation because we're subtracting. And our vector this time is going to be based on this transformation at the top. Okay, so it's going to be 0 as our horizontal component, and then our vertical component is going to be negative 2. Okay, since the a here is the negative 2, we don't have to change the sign this time. Now let's go to my graph, and we need to transform all the points using this vector here, which essentially means we're not changing the x coordinate, but the y coordinate is going to subtract by 2. So we're going to move the points 2 downwards. So let's start my turning point. If I move that downwards, it ends up down here. Now let's go to this point here, which I can read the coordinates of. We move it 2 downwards, it ends up there. Now let's go to the origin, because the graph goes through the origin. We move it 2 downwards, it ends up there. And then we still have a couple of other points that I can read the coordinates of. So this one here, let's move it 2 downwards, it ends up there. And then this point over here, we move it 2 downwards, it ends up there like that. So I can now draw in my curve. It is going to look something like this. So just make sure you're going through all of those marked points when you draw it out. Let's have a look at our next scenario. So we've got the graph of y equals f of x again, shown below. We need to sketch y equals negative f of x. So the function has been multiplied by negative 1. Which transformation would that be? Well, we've got to consider our reflections, and it would be a reflection in the x-axis. So what I need to do is go to all of my points that I can read the coordinates of, and let's reflect them in the x-axis. So let's start with my turning point. Okay, we get 1 up to go to the x-axis, so we need to go 1 up the other side. So that's going to go there. Then for these 2 points, which are on the x-axis, they are not going to move. Okay, they're going to stay exactly where they are. So I'm going to mark them with crosses to indicate their final position. And then let's consider this point here and this point here. Well, both of them have to move 3 down to get to the x-axis. So we have to do 3 down the other side. So it's going to end up here and then over here like that. Okay, so now we can draw our picture in, and we just have to go through all of those points. So it would look a bit like this. And that would be my final answer. Let's have a look at our final scenario. So we've got the graph of y equals f of x, and now we want to sketch y equals f of negative x. So the x inside the brackets has been multiplied by negative 1. So this should be our reflection in the y-axis. So now I need to go to all my known points and reflect them in the y-axis instead. So let's start with our turning point. Well, we need to move 1 to the left to get to the y-axis. So if we move 1 to the left the other side, it's going to end up here. Then let's consider the origin here. Well, it's on the y-axis, so that's going to stay exactly where it is. So I'm just going to mark that point. Now let's consider this point here on the x-axis. Well, we'd have to move 2 to the left. So 2 to the left, the other side would put me over here. Now let's consider this point up here. Well, to get to the y-axis, we move 1 to the right. 1 to the right, the other side, we are here. And then finally, this point over here, well, we have to move 3 to the left to get to the y-axis. So 3 to the left, the other side, leaves me here like that. So now we can draw in my curve, which is going to look a bit like this. And that would be my final answer. We're now going to look at writing the equation of a transformed function when we're given the graph before the transformation and the graph after the transformation. So it says that the graph of y equals f of x is shown on the grid. So it's the left curve is y equals f of x. Then we've got graph A, which is the right one. And it says that graph A is a translation of the graph of y equals f of x. We need to write down the equation of graph A. Now, we're not told the specific equation. It's just f of x. So therefore, our answer is going to be in terms of function notation as well. What I first need to figure out is exactly what transformation has occurred. So we're told it's a translation. So we should be considering the top two parts of my table. Now, given that we have a quadratic looking shape, let's go and investigate the turning point. Well, the turning point here has an x coordinate of 0, whereas the turning point over here has an x coordinate of 2. It's pretty clear that the curve has been shifted to the right. It's a horizontal translation, so we should be considering this translation here, the second one. So the equation is going to be y equals f of x subtract a. We just need to figure out what we're going to write here. So let's write out the vector of my translation. Well, we said it's moved 2 to the right. Okay, so that's going to be 2, 0, like that. Okay, so remember, this value here is the a. Therefore, the negative a is going to be negative 2. So the equation is going to be y equals f of x subtract 2. That would be my final answer. Let's have a look at another question. So in this question is if the equation of the red curve is y equals f of x, okay, what is the equation of the blue curve? So once again, we're going to think about what transformation is going on here. So let's go to the turning points of our red curve. Okay, so our turning point is up here. Well, where is the turning point on the blue curve? It's down here. Okay, so it's moved down 3 boxes. Just check your axes. Is each box equivalent to 1? Well, if this is 0 down here and this is 5, there's 5 boxes between them. So yes, each box is 1. So therefore, it's moved down 3. So I'm just going to write a negative 3 to indicate that. Let's just check that this makes sense for another pair of points. Well, if we look at the other turning point on the red curve, we don't know the exact coordinates of that point. So actually, we're going to look for a different point. Okay, we're going to look for a point that goes for a corner of the boxes. So for example, we could look at this point here. Okay, so if we go 3 downwards, 1, 2, 3, we get here. We're on our blue curve. So it seems that a movement of 3 downwards does indeed check out. Okay, so we've got ourselves a translation. Our translation vector would be 0, negative 3. We haven't moved to the right or left, hence the 0 for the horizontal component. And we move 3 down, so it's going to be negative 3. Now, if it's a vertical translation, which is what we've got here, then we're looking at the top row in our table. So we can write out our equation. It's going to be y equals f of x. And our value for a is going to be our vertical component. So it's going to be negative 3. So that would be the final equation of our blue curve. Let's have a look at one more question. So it says if the equation of the red curve is y equals f of x, what is the equation of the black curve? Now, the first thing I noticed when comparing these is they seem to have been flipped over. Okay, so this time I think we are considering a reflection. So we're looking in one of our bottom rows. So is the reflection in the y-axis or the x-axis? Well, it seems to be flipped horizontally. Okay, so our reflection should be in the y-axis. So we're looking at my third row. Well, the initial function is y equals f of x. So our final answer is going to be simply what is written here. It's going to be y equals f of negative x, like that.